challenges and problems are fuel of victory. So yes, my victorious students, I welcome you all to this awesome platform of Physics Wallah. As you all know, we have already covered our first chapter, that is some basic concepts of chemistry. So today we are going to start our next chapter, that is structure of atom. So students, as the name suggests, the whole story is going to revolve around a single word, that is atom. As you all know, we have covered Dalton's atomic theory in the previous chapter. What was Dalton's atomic theory? According to that theory, atom is the smallest indivisible particle. But students, in today's lecture, we will see that there are various scientists which perform particular experiments and will let us know that atom is not the smallest indivisible particle. It is further classified and is made up of three fundamental particles. Now, what are these three basic fundamental particles? Now, let us move towards our first topic, that is discovery of fundamental particles. The three fundamental particles which I am talking about is electrons, protons and neutrons. So the concept that Dalton's atomic theory gave us was wrong and was proved by various scientists. Now let us see the first discovery. The discovery of our first fundamental particle, which is electrons. The discovery of electrons, also known as the study of cathode rays. It is also known as study of cathode rays. Why it is said to be the study of cathode rays? Because students, we will see that in experiment performed by William Crookes, in which he took the Crookes tube. What he did? He took the Crookes tube, taking the tube about 60 centimeter long, and 2 electrodes were kept in that. Now let me show you that. William Crookes took this Crookes tube. This tube is known as Crookes tube. Why it is known as Crookes tube? Because the scientist that was performing this experiment, his name was William Crookes. That's why. Now, in this side, cathode is taken. And on this side, anode is taken. Right? Here, it is a vacuum pump. Okay, now here it is applied with voltage. Now students, the basic three conditions which we need to remember during this experiment was that high voltage was applied. Why high voltage is applied? See, basically what happens is, in this tube they took hydrogen gas. What they did in this William Crookes tube, they took hydrogen gas. Now, as you all know that gases are poor conductor of electricity. So that's why we took high voltage to conduct the electricity, to perform the experiment and to see the discovery of electrons. So here high voltage is required. High voltage is required. Moreover, low pressure is maintained in the tube, right? You have to also maintain low pressure. Now, what was the experiment? We are going to see one by one. Once I am telling you again, see, 2 electrodes are taken. They are sealed from both the ends, right? Hydrogen gas is inserted inside it and high voltage is supplied here. Why high voltage is supplied? To provide it and to conduct the electricity, because gases are poor conductor of electricity. Now, according to the experiment students, firstly, they took high voltage nearly about 10,000 volts. The second thing, the gas that they took had the pressure about 1 atm. Here, the gas had the pressure was about 1 atm. Right? Okay. The next thing what they did was vacuum pump was applied there to maintain the pressure. You know, they applied vacuum pump to maintain the pressure, to build up the pressure inside. When this condition was there, when pressure was about 1 atm, the thing that they observed was that no current was flowing. When high voltage was there, pressure was 1 atm, no current flows. Right? Okay. Now, when they decreased the pressure, and the pressure was about 1 mm pressure, right? At that spot, what happened, students? Current started flowing. Now here, current started flowing. When the pressure was reduced. Right, students? Now, see, these, you can see, this is the current that is being started flowing, and a colored glow was also observed here. Colored glow was seen. Right? Now what happened was that these colored glow was also seen and the current was flowing, but we were unable to see that what is the thing that is coming from this side to this side. Now, because the speed was very fast, the pressure was again reduced to observe what is the thing that is coming from that portion to this portion. Now, when the pressure was again reduced and the pressure was about 0.01 mm, at that spot, students, now these the cathode rays now were not visible. Hence, to make them visible, we inserted a perforated anode. What was perforated anode? Anode is perforated anode refers to as anode in which a hole is present, through which something can be passed on. That is perforated anode. So here, one perforated anode was built up so that the rays could pass from here, and when the rays were being passed from this end to this end, what was seen? On the spot, on this end, a greenish glow was being observed. Now, see, as I told you, when they were moving, when the pressure was about 1 mm pressure, then we were unable to identify which rays are coming and from which side they are coming and to which side they are moving on. To observe this very clearly, we reduced our pressure. When the pressure was reduced, we have to find the rays, their charges, their mass, and so we observed that after applying the perforated anode, a greenish glow was observed. So at that spot, students, what happened? At that spot, greenish glow appeared. Right? Okay. Now, this was the basic experiment which leads us and explained us that something was coming from cathodic end towards anodic end, and that's why if it was referred to as cathode rays, because it was coming from cathode towards anode. So we discovered about cathode rays. That's why when we speak about the discovery of electron, we refer to it as discovery of cathode rays or the study of cathode rays, because the rays which were coming from cathode are referred to as cathode rays. Now, how can we compare electron with cathode rays? This thing arose in our mind, and so J.J. Thomson, according to his experiment, gave us that the properties of cathode rays are similar to that of electrons, and so he compared both of them. Now, what were the properties of cathode rays? The very first property was that they can travel in the straight line. How they had proven that? Students, you can see that whenever a solid object was placed in the path, in the tube, the shadow was seen. And when will be the shadow seen? When you put some light over it. For example, I am standing in a path, right? You put a torch behind me, so a shadow will be seen. The same was seen and observed in the case of this William Crookes tube. What was seen? That a solid object was placed and a light source was passed on so that a shadow was placed over. Now, if the rays are traveling from behind that and will move in a direction toward forward, then only this could happen. That means cathode rays are traveling in a straight line, are traveling in a straight path, right? So the number first thing, the property of cathode rays is they produce a sharp shadow of the solid object placed in their path. This shows that cathode rays travel in straight line, students. Now, the very next thing is that the next property that explains us that cathode rays are made up of material particle or they have some kinetic energy was explained by the paddle wheel. If a paddle wheel is kept in the William Crookes tube, what was seen that it starts to rotate. It starts to rotate. Hence, they possess some kinetic energy, or we can say that they are built up of some of the material particles. Here you can even add that they possess some kinetic energy. That is why it leads the wheel to rotate, to move, right? So the second property is if a light pedal wheel that of mica mounted on an axle is placed in their path, the wheel begins to rotate. This shows that cathode rays are made up of material particle. Now moving towards the third property, what was observed, students? In the third property, it was shown that cathode rays carries negative charge and electrons are also negative charge. Hence, we can compare both of them. Okay, so how was this proven? This was proven because as cathode rays were negative charge, when a particle is said to be negative, when it is approaching towards positive, right? Because positive and negative both attract each other, while negative or positive repel each other. So when it was seen that the rays were attracted towards the positive path, it concludes us that it is negative, because negative is always approaching towards positive. If it was already negative, then it would have been repelling each other, right? So here, when an electric field is applied on the cathode rays, they are deflected. They move towards the positive plate of the electric field. And when something is moving toward positive, it is already a negative thing. So cathode rays carry negative charge. This proves that they are electrons, right? So here was discovery of electron proven to us. Now students, the next property which tells us about the cathode rays is that when a magnetic field is applied, see, when we first applied electric field, we got to know that they carry a negative charge. When a magnetic field is applied, during this process, these rays are deflected in a direction which shows that they carry negative charge. So it's all about the way in which they travel and towards which they deflect, right? Here they deflect towards the positive end, hence they are known as negative. There also they are deflecting in such a direction, hence they are referred to as negative charge, right? So see, in this diagram you can clearly see these are the cathode rays that are being traveled, right? After applying the electric field, here this is the electric field that is being applied. Okay, when the electric field is applied, it is moving in this direction. When it is moving in this direction, we can see the positive end is towards upward, so it is moving towards positive. If it would have moved to a downward, that means it is moving to a negative, but negative repel each other. Hence, when it is moving in this direction, it depicts that it carries negative charge. Now, coming towards this diagram, I am showing you that magnetic field is applied from the downward direction. So, what we are observing here, when the cathode rays are traveling, this is our perforated anode which carries a hole. Now, cathode rays are traveling from in between them. Now, it is moving in a path where it is getting positive. So hence it concludes that it is already a negative charge because it is moving towards a positive charge. Now coming towards the further next properties of cathode rays, we could say that cathode rays are basically, they possesses heating effect, because what happens is when cathode rays strike a metal foil, it becomes hot. That means they produces heating effect. Now students, the next property is that they cause ionization of gas through which they pass. That means ionization refers to as that it split into ions, right? So it ionizes the gas, right? The next further point is they produce X-rays when they strike against the surface of hard metals. The X-rays are produced. Now, what are the hard metals like tungsten, molybdenum, right? Or phosphorescent or fluorescent substances such as zinc sulfide. X-rays are produced in that case. Now, the very next property is that they affect the photographic plates also. And the last property is that they possesses penetrating effect. Now, what do you mean by penetrating effect? Penetrate means to move inside something. Okay, they can easily pass through thin foils of metals. They are stopped only by the metal foils of greater thickness. Otherwise, they won't be able to stop. They could totally penetrate and move from inside towards outside, right? So these were the properties of cathode ray, students, which was observed by J.J. Thomson with the help of William Crookes experiment. Now students, coming forward to explain the charge and mass of electron, first of all we are going to see the charge to mass ratio. Now, what do you mean by charge to mass ratio and how it helped us in calculating the charge of electron, in calculating the mass of electron? So there were two experiments that was performed. Now, the number first thing was done by J.J. Thomson. What he did that he took cathode, he took perforated anode. Please mention here perforated anode is taken. Again, I am explaining you, perforated refers to as when our anode has a hole in between so that a particular rays could travel through in and out, right? Now students, what happened is, these are our rays that are being traveled from cathode towards the anode. Now, according to J.J. Thomson, two kinds of field were applied. One was the electric field and the second one was the magnetic field that was applied. Why is it was applied? To calculate the charge to mass ratio. That's why, students. Now, let us see this. When he applied electric field was applied in this direction, right? Positive and negative, you could easily observe that. As you all know, cathode rays are negative charge, so they will move towards positive charge according to the experiment. So you will see a spot. When you will see a spot when electric field is applied. The second most thing you should observe is when magnetic field is applied. Now magnetic field is applied from below. So when magnetic field, let me write here, it is electric field. It is electric field, so it is striking towards the A point, right? Okay. And when it is magnetic field which is applied from the downward direction, it is the spot C where our rays is being striked. So this is our magnetic field, and spot B refers to when both are equivalent. When both are equivalent, that refers to the B spot. Now, what do you understand from the following diagram? What are we getting here is, students, that when both the fields are applied, then J.J. Thomson calculated charge to mass ratio. He took different electrodes, he took different gases, and then he saw that charge to mass ratio was same when different electrodes and different gases are taken. Now, what was the value that was observed in all and they were same? The value was about 1.76 into 10 raised to the power 8. This was the value and the unit were coulomb per gram, right? It was same when different electrodes and when different gases were taken. Before this experiment, when William Crookes performed it, he took only a particular kind of gas, that was hydrogen gas, and he applied different pressures and he observed that. But now what did J.J. Thomson did? He took different electrodes on both of the ends and he took different gases inside them and observed that. Right, students? So the specific charge, specific charge of electron is independent on the nature of gas. Do remember that also. Now, this was charge to mass ratio that was being observed. According to this experiment which was being performed, what was the basic things that were kept in mind of J.J. Thomson? He saw that the deviation, like it is moving towards A, it is moving towards C, it is moving towards B. These deviations usually depend upon the three basic factors. What are the three basic factors? Number one is the magnitude of the negative charge on the particle. The next thing is the mass of the particle. Okay, the particle's mass. The third thing is the strength of the magnetic field, right? How much magnetic field you are applying to them. Now, these are the basic three things due to which we could see the deviation towards A, the deviation towards C, or the direct path towards B. These three factors are responsible for that. Now students, now these all things which I've already told you are being written here. Let me dictate it to you. When electric field is applied, deviation from path takes place. We have seen the deviation, it is moving towards A, right? If only electric field is applied, cathode rays strike at A, right? If only magnetic field is applied, cathode rays strike at C. In the absence of any field, or when both of the fields are equivalent, they strike at B. The rays strike at B, right? Okay. Now students, according to the experiment which is done with the J.J. Thomson, we got to know about the charge of electron. We got to know about the charge of electron with the help of charge to mass ratio, right? And the charge of electron was about minus 1.6 into 10 raised to the power minus 19 coulombs, right? Okay students, so this was our charge of electron. Now to calculate the mass of electron, one more experiment was performed, that was Millikan's oil drop experiment. Now what is Millikan's oil drop experiment? As the name suggests, it was performed by Millikan, and oil drop experiment refers to as that we are taking oil droplets. Now, how to take oil droplets? An atomizer is kept. Atomizer contains oil droplets, and in the form of mist it is being applied, right? In the form of mist, in this atomizer, oil droplets are kept. These oil droplets are sprayed like this. Now, what happens is, this is the inner section of the chamber that I have shown you through the help of this diagram. You can see that there are two basically plates present here. This is the plate which has the small hole in between, and the lower plate is negatively charged. These two plates are kept in between this structure, right? Now what happens is, students, you have taken a telescope here to observe what is happening inside, and on the other hand you can see the X-ray from the source. X-ray here is kept to provide the ionization, to provide the electrons, right? Okay, now what you have to observe is, you are observing that when atomizer, you spray the atomizer in such a condition that oil droplets in the form of mist travel inside. Now when oil droplets are traveling in the form of mist, they have to travel from this hole, from this particular hole, they have to move down, right? How will they move down? One by one? Yes, one by one the oil droplets will move towards downwards. Now what is happening, students? Oil droplets, when they are moving towards downwards, the X-ray from the source liberates electrons. The oil droplet is now surrounded by electron. For example, this is our oil droplet. These are now surrounded by electrons. When these are surrounded by electrons, the oil droplet is unable to move towards downward. Why it is unable to move toward downwards? Because downward is a charged plate which is already negative, and negative repel each other. Okay, so negative which will repel each other will push the oil droplet towards the upward position. But what happens is, students, the gravitational force brings the oil droplets downwards. So two forces are happening here. One force is like electrostatic force, one is like negative are repelling each other, another one is gravitational force. So due to this condition, due to these two fields which are being held here, we are able to calculate the charge and mass of electrons. And when we are able to calculate the mass of electron, it came out to be 9.11 into 10 raised to the power minus 28 grams. Okay, so this was our mass of electron, and this mass of electron was about 1 by 1/837 of the mass of hydrogen, So this was the most important concept which we need to keep in our mind, and so we can define electrons as, electron is that fundamental particle which is negative charge. Now understand first the definition, then we'll elaborate it, right? Electron is the fundamental particle which carries a negative charge and whose mass is equal to 1 by 1/837 of the mass of hydrogen. Now, splitting it definition into the following types, one by one, I would say that electron is a fundamental particle. Why it is said to be as fundamental particle? Because it is responsible for the formation of atom. We already understood that atom was not indivisible, right? It is further divided into three categories. So we got to know the fundamental particle term. Now, it has negative charge. from where this term came, negative charge? It came from the discovery of cathode rays. We studied there that it carries a negative charge. Okay. The very next thing is that it has a mass which is nearly equal to 1 by 1837 of hydrogen. It came with the help of Millikan's oil drop experiment. So we can now define electron in a very good definition, right? So this is the Millikan's oil drop experiment, which I've already explained you step by step. Now let us read it to make it more clear. In the experiment, some fine oil droplets were allowed to enter through a tiny hole into the upper plate of electrical condenser. Now this is the upper plate, okay, and with the help of atomizer, we will spraying the oil droplets in the form of mist. They were traveling and they were allowed to move so that they could enter through the very first plate, right? Okay. These oil droplets were produced by atomizer, as I have already told you. The air in the chamber was subjected to the ionization by X-rays. Right, students? Okay. The electrons produced by the ionization of air, I already told you that X-rays are going to produce the electrons. Now they will surround the oil droplets, right? Okay. Electrons produced by the ionization of air attach themselves to the oil droplets. Now this will cause and leads towards the calculation of mass of electron, right? Thus, oil droplets acquire negative charge. Now they have negative charge around them, right? Okay. When sufficient amount of electric field is applied, the motion of oil droplets can be accelerated. Now we will see the motion of electrons, right? Retarded or made stationary. What we can do is, like, we can increase its motion, we can decrease its motion, or we can make its motion stationary, almost still, right? Okay. Millikan observed that the smallest charge found on them was about minus 1.6 into 10 raised to power minus 19 coulomb. Now this is the charge of electron, right? And the magnitude of electrical charge Q on the droplets is always an integral multiple of the electrical charge. That is, Q is equals to N into E, where N can be 1, can be 2, can be 3. Now here Q refers to as the charge, They are saying that the magnitude of electrical charge Q, which is present on the droplet, is always an integral multiple of the electrical charge that the electrons are carrying. Clear? The oil droplet, which has a charge, will depend upon the charge of the electrons that are surrounding them. So this was the Millikan's oil drop experiment, which helps us to calculate the mass of electron. Now students, this was the discovery of electron. We will proceed toward the discovery of a proton. It is almost similar to the discovery of electron, just the basic difference will come in the charges. So students, proton was discovered by Goldstein, and during the discovery of electrons, there were some things that were quite different from discovery of proton. What were these different things that are being observed? First of all is the charge. Electrons are negatively charged while protons are positively charged. How can I say that positively charged particles are protons? This is also concluded by the same, Crookes tube. How? In this particular tube, you can see both of the discoveries, the discovery of electron as well as the discovery of proton. First of all, don't get confused with the previous diagram. In the previous diagram, on this side, we have taken cathode. On the other end, we have taken anode. But in this diagram, students, we have done the opposite. I have taken cathode on the other side and anode this side. Now, if I talk about the discovery of electron, if I take cathode from that side, that means the rays are going from that end towards this end. That means if I am taking this red pen, I would say, now these are my cathodic rays. If I take cathode on that spot and anode on this spot, then that means the rays that are coming from cathode towards anode are cathodic rays, right? So these red ones are our cathode rays, which explains us about the discovery of electron. Always remember these things, which electrode you are considering on which side. Like in previous case, we considered cathode this side. Now we are considering cathode that side. This is all concept. That's it. Nothing else. Okay. Now, cathode rays already studied. Now what are our discovery of protons, or I would say canal rays? For protons we are using canal rays or anode rays. Now what are these anode rays? Just opposite to cathode rays. If our cathode is basically the negatively charged, then our anode is the positively charged. Why anode is the positively charged, ma'am? Because atom is basically a neutral. It is neutral. Neutral refers to as the total positively charged and the total amount of negatively charged both are equal. If there is something negative, then for sure there will be something positive also. So if there is something negative, that means if there is cathode rays present, then there is something positive, which is our anode rays, which is our canal rays, students. Now what are the canal rays here, or what I would say is the is our anodic rays. See, cathode rays are the one that travel from cathode towards anode. Hence, the opposite will be anode rays are the one that will travel from anode towards cathode. Now, this is our anode, as the diagram is just opposite to the previous one. So, anode rays are the one that is going from anode towards cathode, and it is seen that during the discovery of proton, when the anodic rays which move from anode towards the cathode strike on this ZNS screen, okay, and here it is observed, here it is seen on this ZNS coating, it is being seen that some rays are coming from anodic side, and so they refer to as anode rays or canal rays. Hence they are coming from anodic side, they are positively charged particles, because cathode rays are negatively charged particles. Now the properties of proton. What are the properties of proton? Number first property of proton is that they carry positive charge. They carry positive charge. Okay. Now what will be the second category? They produce heating effect, students. They produce heating effect. Okay. Now the next property is that they travel in straight line, right? They travel in straight line. It is also been proved how they travel in straight line. If you keep an object in their place, they will produce a shadow effect, just similar to that of electrons. So they also travel in, students, straight line. Okay, now they are deflected by magnetic field. During the discovery of electron, we already told that they are deflected by magnetic field. Why? Because they move in direction towards the positive end. Now they will move in the direction towards the negative end because they are positive in nature. Right? Okay. They also possesses kinetic energy. The next property is that they possesses kinetic energy. Now, students, these were the properties that we studied in the discovery of proton, but the thing that was different from electrons is that in electrons, I already told you that, students, our specific charge that we studied in electrons, that was independent on the nature of gas, but in protons it is dependent on the nature of gas. And also one more thing, students, in electrons we have studied the charge by mass ratio. In electrons, for different gases and different electrodes were same, but in the case of protons they are not same. Right? So these were the basic and little things that are different from each other. Now, students, comes the charge and the mass. Right? If I talk about the charge of electron, let us make a box here and write in it. Okay. Firstly, we are going to write the charge of proton. Students, the charge of proton is same as that of electron. It's just that electron is negatively charged, so negative sign comes in front of it, and proton is positively charged, so positive sign comes in front of it. That's it. That is the same thing. Positive come and the numbers are same. 1.6 into 10 raised to the power minus 19 coulomb. This thing is almost the same as that of electrons. In electrons, what is the charge on an electron? Minus 1.6 into 10 raised to the power minus 19 coulomb. But in proton, what we observe is positive 1.6 into 10 raised to the power minus 19 coulombs, right? Now, students, this was the charge. Now, what is the mass, right? We are going to write the mass of proton. Students, in electron case, we have seen that the mass of electron was 1 by 1/837 of the mass of hydrogen. Now, in the case of proton, if I ask you about the mass, in the case of proton, it is same as that of hydrogen atom. It is about 1.6 into 10 raised to the power minus 24 kg, right? So, here it is almost same to that of hydrogen. 1.6 into 10 raised to the power minus 24 kg, students. This is the mass of protons. Clear, students? These two things you need to remember in all of these three cases, like in case of electron, in case of proton, in case of neutrons. So this was the discovery of proton, which we have seen that they are positively charged. They have charge almost similar, just the sign is different, and yet the mass is also different from that of electron. Students, one more thing. How would I define proton? As I defined electron, in the same way I'm going to define proton. Proton is that fundamental particle. Now, fundamental particle are those particles which stated us that matter is not indivisible. It is further divided, into electron, proton and neutron. So the basic definition is always starting like this, that proton is a fundamental particle which has a positively charged. How positively charged? Because it is coming from anode towards cathode. We have seen they are going from anodic side towards the cathodic side, so they are positively charged, and hence their mass is almost similar to that of what? Hydrogen atom. So this is going to be the definition for the proton, students. Now, as we have studied the discovery of protons, so one thing that each and every student need to keep in their mind is that always think like a proton. Why? Because proton is always positive. So positive thinking, students, is very, very necessary for any examination, whether it is your boards, whether it is your competitive, any exam. If you have positive thinking in your hand, if you have the control over your mind that you need to think positive every time, in every situation, in every challenge, then you can accomplish anything. You can gain victory anytime. Okay, so the continuous, repetition of your work, repetition of your questions, when you solve any question, when you lose your confidence, just remember, think positive, think like a proton. That's it. Clear? So discovery of proton taught us to think like a proton. Now, coming towards the discovery of neutron, students, the neutron discovery, it was given by Chadwick, and he explained us that when alpha particle was bombarded on beryllium, alpha particle is what? Alpha particle is our helium, right? This is our alpha particle. When alpha particle is bombarded on beryllium, what was observed? Neutron was produced. So students, neutron was produced by the bombardment of alpha particle on beryllium. And this experiment was done by Chadwick. So what we concluded here? We concluded that neutron is basically neutral. That means it has no charge, right? And what is mass? Mass is that similar to that of proton. That means when I come to define neutron, I would say that neutron is the fundamental particle which has no charge and mass is equal to that of hydrogen atom. Okay. Now, let us also write the definitions for the electrons and protons so that you can keep in your mind, right? Okay. If I talk about electron is the fundamental particle which has negative charge and whose mass is equal to 1 by 1/837 of the mass of hydrogen atom. Mass of hydrogen atom. And last is our proton, right? Last is our proton. So what would be the definition of proton? I would say that proton is the fundamental particle which has positive charge and whose mass is equal to that of hydrogen atom. Right? So students, kindly put a star mark over here and do remember this. Because it is going to help you in your examination. These three definitions, please put a star mark over it or write in your NCERT so that you can remember the charge and the mass over these three fundamental particles, right? So this was the discovery of our fundamental particles. Now we are moving forward towards the atomic models. Now, as you all know, we have discovered that atom is divisible and we have already studied the fundamental particles. Now what is the atomic model? Atomic model refers to as the basic structure which defines us that how does an atom look, what is the representation of an atom. Students, the basic concept for the atomic model was done by Thomson, and Thomson just saw this atom and he remembered watermelon. He remember the raisin pudding model, so he compared it with the watermelon and he said that atom is basically a positively charged species in which electrons are embedded, just like a watermelon in which red portion is the positive one and the seeds which are embedded in between them are the electrons. So this was the comparison which he did with atom and with the watermelon, so that the people could understand the basic structure of an atom. And hence he defined the positively charged particles and the negatively charged particles. He said that the negatively charged particles are electrons, while the positive ones are the other regions, other than electron. And this concluded that the whole atom is neutral because the total positively charged is equal to the total negatively charged. So this was the basic concept that he want the people to understand, that atom is neutral in nature, right? So the first thing that he concluded in his model is that atom is neutral. The second thing he said that is electrons are embedded in the atom, just like seeds in watermelon, right? He also concluded that atom is full of positively charged species in which electrons are present. I want to conclude that this is the positively charged species in which electrons are embedded. I'm talking about this. I'm not talking about the whole portion of an atom. Whole, it is electrically neutral. Okay, whole it is electrically neutral, but I'm talking about the portion that the other region is positive, and some of the region where like seeds are embedded, they are electrons, right? Now it failed. Why it failed? Because it could not explain the scattering experiments that were performed by Rutherford. Now, what is the Rutherford scattering experiment that helped us to understand about atom? According to the Rutherford scattering modeling experiment, according to the definition or according to the word, I would say scattering refers to as when a ray is passed. Okay, when a ray is passed, it gets scattered, it gets deflected in its path. It doesn't go straight. That refers to as scattering, or that refers to as reflection, right? Now what happens is a radioactive source was taken. Radioactive source was taken and alpha particle was splitted out from that. Now the beam of alpha particles, these are the beam of alpha particles that are moving, right? The beam of alpha particles strike over the gold foil, and what is being observed here? Some of the particles goes straight. Some of the beam of particles are going straight, while some are deflected with a certain angle. Some are deflected with a certain angle, while students, some are reflected back. What is seen that some of the beam of alpha particles passes straight through the gold foil. Some of them are deflected through a particular angle, while a very few are deflected back. Now, what is this condition? Why is it happening? It is going to make us understand about the atom. All we are getting here, the conclusions will help us to understand the structure of atom. How I am saying? See, if I make, let us make an atom here. For example, this is my atom, right? If I consider this is an atom, right? According to the Rutherford model of atom, what he said that most of the rays passes straight. Now see, what I'm doing is most of the rays are going to pass straight. Okay. These are the rays, students, that are passing straight. Okay. These are the rays which are almost 99.9% which are passing straight. Now comes the next ones. Now comes the next ones which are deflected by a particular angle. Now, these are the rays which are deflected by a particular angle. Right? The green ones are few less than the white ones, okay, but they are deflected by a small angle. And then comes the last one. Then comes the last one which comes and are deflected back, which are going in this direction but are deflected back. Now, what is the conclusion you are observing in this structure? We are observing that in the centermost position, here, there is something that doesn't let this yellow line to cross over it. What is this? What does it refers to as? It concludes that there is something mass is present in between this atom that lets this yellow rays to deflect back to its mean position. It refers to as that atom contains some heavy particle inside it. Now, what is this heavy particle that is present inside it, and why it is not present all around it? So, from here we conclude that, students, the rays which are passing straight explains us that atom basically has empty space around it. One by one I am going to explain you. The white portion explain us that there is a lot of empty space present in an atom. Okay, we are going to write it one by one so it will be easy for you to understand, right? First thing you need to write is conclusions. Or observations you can do. We could write observations, that could be a much preferred word. Observation. So what were observations? The observations were that atom has empty space inside it. In the bracket you can write because 99.9% rays pass straight. because 99.9% rays pass straight. That's why it explains us that there is something empty space, this area, from where the white lines are being passed. Now comes the green one areas, that they are being reflected. Why they are being reflected? That means, alpha particles are basically the positively charged species, right? And reflection is observed when a positive strike towards the next positive, right? So that means at the centermost position there is something positive. That's why when something is coming nearby, it gets deflected. What is it is explaining to us? It explains to us that the center of atom is positively charged, as some rays are reflected by small angles. Okay, now the third conclusion is the yellow one. It concludes us that there is something heavy present inside it, because if I'm moving from this direction towards this direction, if I have someone of my weight, so only I could be pushed back to my mean position. If I have someone who has very much less weight than me, then I could push him or her away and move toward forward direction, right? So there must be something that could compete with me in my direction. That means there is something heavy present inside it that is pushing it and doesn't letting it towards to move forward. So we could all say that this centermost position of the atom, which is known as nucleus, is heavy. So all I can say that the center is heavy, the center portion is heavy, or we can say the nucleus is heavy, because the rays are deflected back. These are some rays, very few rays are reflected back. Clear, students? So these were the observations that we made from the Rutherford model of atom. Now students, according to this diagram, I have shown you a single atom, Now it also explained it to us about the two parts. That atom basically consists of two parts. What are these two parts? Nucleus and the extranuclear part. Now these two basically is the conclusion that we make from this model. Now what are these conclusions? First of all comes the nucleus. As you all know, nucleus, I have already told, something is present at the center and it is heavy. That means nucleus is present at the center and it is heavy. And students, nucleus, if it is present at the center, I have already told that the center of the atom is positively charged. Hence we conclude, we conclude that nucleus is positively charged. This I have written positively, don't get confused. Positively charged, right? And if nucleus is positively charged, nucleus basically comprises of neutrons and protons. It comprises of neutrons and protons, because basically if I talk about electrons, then you can see the charge on electrons and the charge on the protons, right? If I talk about electrons come under the area of extranuclear part. In the nucleus, it is only the positively charged species. Neutron has no charge and proton is positively charged. Hence, nucleus comprises of both of these, protons and neutrons. Okay, and it is heavy. It is also heavy. Okay. The second basic thing which we have observed is extranuclear part. Extranuclear part basically comprises of electrons that are revolving around the nucleus, or I can say they are embedded in the nuclear part. Electron basically revolves around the nucleus, or they're embedded in the extranuclear part, that is other than nucleus. So this was the conclusion. If you want to make the Rutherford model of atom in a very big way, so you can make like this also. So what I'm going to explain is the same thing, that there are some rays that pass straight. That explains us that atom basically has a lot of empty space inside it. The second most thing that we conclude here are that, some rays are present that are being reflected by few small angles, they are reflected by few small angles. And there are, students, some rays that are deflected back. There are some rays that are deflected back like this. So these are the basic conclusions that we observed in the Rutherford model of atom. Okay, so this was the model of atom. Now we are proceeding towards the very interesting topic of structure of atom, that is going to be atomic number and mass number. Basically, students, to understand atomic number and mass number, first we need to understand about electron, protons and neutrons, which we have already covered. Students, we represent atomic number as capital Z and mass number as capital A. So to represent any atom with the help of atomic number and mass number, how will it show us? See, to represent it, I am going to write an element X. We are assuming there is an element X. Now, I have to show atomic number and mass number over here. So, atomic number is always placed below as Z and mass number is always placed at the above as A. Clear? So atomic number is capital Z while mass number is capital A. Now, what do you mean by atomic number? Whenever we are arranging all the elements in periodic table, each and every element is assigned a number which is known as atomic number. Basically, atomic number is the number of protons that is present in the atom. Okay, so all I would say is atomic number refers to as the number of protons in any atom, right, students? So all I can say is, if it is Z, then it is equal to P. P refers to as the protons. Now students, I am talking about mass number. Mass number refers to as for nucleus. How is nucleus comprised of? An atom basically consists of protons and neutrons, and electrons just revolves around them, right? So that means mass number is the sum total of neutrons and protons, right? Because electrons will be revolving around them. So mass number, which is represented by capital A, is equal to number of neutrons plus number of protons. Students, neutrons are shown by small n, while protons are represented by small p. Now, as you all know that Z is equal to P, so in short you can write as mass number is equals to N plus Z, right? Now, other than this comes electrons. In neutral cases, remember that in neutral cases, number of protons is equal to number of electrons. Neutral case refers to as when the charges are equal. When both of the charges are equal. When the charges are different, the number of protons and electrons are also different. For example, if I talk about any atom, sodium atom, that refers to as a neutral compound, but neutral species. If I talk about sodium ion, that means it has a particular charge over it. And when a particle has a particular charge over it, then we see that the number of protons and neutrons are not equal. So at that case, that is not a neutral molecule. So for a neutral molecule, number of protons and number of electrons are almost same. That means for that case, we can write that atomic number will be equal to number of electrons. For what? For neutral cases. Why? Because atomic number is equal to proton, and if it is a neutral species, then it is equal to electron as well. So one of the examples if I would take is of carbon. Let us take of a carbon. Now how to represent it in this form? First, I am writing in the place of X the carbon element alphabet C. right? Now the next thing I have to represent is atomic number as well as the mass number. I know that carbon's atomic number is what? Carbon's atomic number is, you can see hydrogen, helium, lithium, beryllium, boron, carbon. It's 6, right? The first 30 elements you need to remember so that it will be easy for you to understand the periodic table, right? So it is 6. Now what is the mass number of carbon? It's 12. Mass number is 12. So if I ask you about number of electrons, number of protons, number of neutrons, in this case, what it would be? I told you that whenever you see a species like this, you have to first compare this with it. Okay. Now, X here is carbon. That means we are talking about carbon atom. The next thing is that Z is being replaced by 6. Z refers to as the atomic number. So, we can say that here atomic number is 6. Here atomic number is 6. Now, if atomic number is 6, which is Z, Z is always equals to number of protons. Hence, I can say that in this case, protons is equals to 6. Okay. Now, tell me about neutrons. What is the value of neutrons? To understand neutrons, we should remember this basic formula of mass number. This basic formula of mass number. Mass number A is equals to number of neutrons plus number of protons. So, all I would say is A is equals to N plus P. I have already found that P is 6 and A here. This is A, right? So A is 12 and P is 6. If I take this here, if I write in this form, 12 is equals to N plus 6. So all I would conclude is N is also equals to 6. That means in this case, number of neutrons is equals to 6. So I have already found mass number A, which is 12, atomic number Z, which is 6, number of protons, which is 6, and number of neutrons, which is 6. Now what is left out here is number of electrons. Now students, please tell me what is the value of electrons here. Most of you have found that one of the lines which I've already mentioned here is in neutral cases, when there is no charge given to you, number of protons will be equal to number of electrons. So we can conclude that if your number of protons are 6, then our number of electrons will also be equal to 6. So all I would say is electrons are also 6 here. Clear? So in this manner, you can easily find out atomic number, mass number, number of neutrons, protons and electrons. Now let us take an example. Students, calculate the number of electron, proton and neutron in both of these cases. The first case is sulfate ion. See, the simplest form of carbon I have already told you. Now both of these cases are of charges. If some charge is present over it. So how would you calculate electron, proton and neutron in these cases? First of all, sulfate ion, which is represented as SO4 2 negative, right? See, neutral species doesn't show any charge above, but any species which have a charge is represented at the top of it. Right? Here it is written -2. That means charge is there. So all I can say is, if I have to find out what is here the number of protons, first of all I will find out number of protons. How to find out number of protons? We know that number of protons is equal to Z, which is atomic number. So first of all, in this compound, we need to find out the atomic numbers for the particularly elements, right? See, here you can say that SO4 comprises of like this. I'm not taking this charge for once. I'm ignoring this. I'm just writing SO4. Now students, sulfur basically, what does sulfur has atomic number? Sulfur has atomic number 16 while it has mass number 32. While practicing questions, you will get to know and you will get to, understand these concepts. So sulfur has atomic number 16 as and mass number as 32. While if I talk about only oxygen, I talk about here 4 oxygens are present in SO4. I am taking a single oxygen for once to you to understand. Oxygen basically has atomic number 8 and mass number as 16, right? And I have 4 oxygen here. So if I consider only this sulfur, what is the atomic number here? 16, which is equals to number of protons, which we have already studied. And if I talk about oxygen, what is Z? Z here is 8, which is equals to protons. Okay, so I have found for the case of sulfur, the number of protons is 16, and for the case of oxygen, the number of protons is 8. But I have seen that there are 4 oxygen atoms present here. So I need to multiply it with 4 to find for all of the 4 oxygen atoms. Hence, 4 into 8 is 32. So all I would say is that sulfur has protons 16 while 4 oxygen has protons 32. So total number of protons in SO4 would be here. total number of protons would be, it will be 16 plus 32, that refers to as 48. So I have concluded that there are 48 number of protons present here. Okay, now please tell me what will be the number of neutrons here and what will be the number of electrons here. Students, to conclude that, to find neutrons we need to find what? We need to find mass number, because we know that mass number is equals to neutrons plus protons. I have already found the protons value. You know, if I find the mass number value, I can easily calculate the neutrons. Now let us calculate the A value, that means the mass number value. For sulfur the mass number is 32, it's already shown. For oxygen it is 16. But how many oxygen atoms are present there? Total, basically there are 4 oxygen atoms present there, right students? So all I could say is that if there are total 4 oxygen atoms present there, so 4 into 16 plus 32, these are going to be A, right? So I would say 64 plus 32 is A, 96 is A. Now mass number I have already found, it's 96, but we need to calculate number of neutrons. Hence 96 minus protons will give us neutrons. So I would say 96 minus 48 will give us neutrons, because protons is 48 number. So here we conclude that 48 is the number of neutrons, right? Number of neutrons comes out to be 48 and number of protons also comes out to be 48. So we have already found that sulfate ion contains 48 neutrons and 48 protons. And the number, last thing that left is electrons. How many electrons are present here? As you all know students, whenever we talk about charges, if remember that if any negative charge is present over there, you need to add that in the electrons. If there is any positive charge present on the species, you need to subtract it. So here it is -2, that means I have to add it, right, in number. See, all I would say is, for neutral, I would say protons is equals to electrons, right? If I consider this as a neutral, then I would say protons is electrons. So number of protons is 48, so electrons will be 48. But now I am coming towards my case again, and I have negative charge, -2 charge. And I already told you, if there is negative charge, you need to add that number. If there is positive charge, you need to subtract that number. So -2 will be added here. Hence, we will find the number of electrons, which comes out to be 50. So for this case, we have already found that electrons are 50, protons and neutrons are 48 and 48 respectively. Right? Now comes the phosphate ion. Okay. Now we will see the case of phosphate ion, students. Right? Okay. Phosphate ion. Phosphate ion. Basically, phosphate ion is PO43 negative. So students, we have to do the case similar to the previous one. What we need to do is individually, first of all, we have to calculate number of protons, neutrons, electrons for individual element. Then we need to add them together for the following compound, right? So what I'm going to do is I'm going to write phosphorus and oxygen individually. First of all, first we will write phosphorus, here we will write oxygen. So phosphorus basically has atomic number as 15 and its mass number is 31. If I talk about oxygen, it has atomic number as 8 and its mass number is 16, right? So now what we need to do is we need to calculate number of protons and number of neutrons for both of these cases. If I talk about phosphorus, students, so I would say number of protons is equal to the atomic number. So protons here is 15. And if I talk about neutrons here, so what is the neutrons? Atomic number, which is basically referred to as protons. So we can say that mass number is equals to number of neutrons plus number of protons. Here is the formula, right? If I have mass number A as 31 and if I have proton as 15, so what will be the neutrons? I would subtract them. So it comes out to be 16. Okay. If I talk about the electrons case here, in the phosphorus, what will be the electrons? Electrons will be equal to that of protons, which is 15. Now coming towards the oxygen part, what is the number of protons? Protons is equals to the atomic number. Atomic number is 8, hence protons is also 8. But students, how many oxygen atoms are there? 4 oxygen atoms are there. So I will multiply it with 4. Hence it comes out to be 32 for the case of oxygen only. right? Now if I talk about neutrons, what will it will be mass number minus Z, mass number minus protons. 16 minus 8 is 8. How many oxygen atoms are there? 4. So it comes out to be again 32. If I talk about electrons, for the case of oxygen, I would say it is equal to number of protons. I am not including the charge right now. I'm just doing individual element. Don't get confused. At the end, I'm going to calculate that also. So if I talk about electrons, I would say 16 minus 8 is 8, right? Again, it for 4, it will be 32. Now student comes the calculation time. So here you need to do is you need to calculate for all of them together. Like for PO4 minus 3, right? So if I talk about protons, what will be protons? For phosphorus it is 15, for oxygen atoms it is 32. It comes out to be 47 students. It comes out to be 47. If I talk about neutron students, neutrons for phosphorus it is 16 and for oxygen atoms it is 32, which comes out to be 48. And if I talk about electron students, so if I count for phosphorus it is 15, while for oxygen it is 32, and there is minus 3 charge. I already told you, if there is negatively charged species, then you have to add it. If there is positive, then you have to subtract it. So it is given minus 3, so you will add it plus 3. So what comes out here to be, it's 35 plus 15, that's come out to be 50. So this is the correct value if I would say for number of electrons, number of protons and number of neutrons in the case of PO4 minus 3. Clear students? Now comes the very interesting topic. So students, now we are doing isotopes. Basically all these terms contain the common word, that is iso. Iso refers to as same. So we are going to see something is same in all these cases, right? So first of all, I am coming across isotopes. As I said you, iso refers to as same. So isotopes, we see that when the atoms of same element, please do note that atoms of same element have same atomic number but different mass number, are referred to as isotopes. Atoms of same element have same atomic number but different mass number. So I'm directly writing mass number as A so that you can understand. We have already done that, right? Atomic number I am directly writing as Z. So one of the examples of these are the isotopes of hydrogen students. Hydrogen have basically 3 kinds of isotopes, that is protium, deuterium and tritium. Okay, so here I'm going to write it thrice because its representation is with the capital letter H. Now students, its atomic number is going to be same, that is 1, but the mass number is different, that is going to be 1, 2 and 3. So this is the very first case. The next example which we could take is of chlorine. So chlorine has atomic number as 17, while one of the mass number is 35 and the another one is 37. So these are the cases of chlorine. So isotopes of chlorine are also very most important and isotopes of hydrogen are also important. So you need to keep both of these examples in your mind. Right students? Okay. Now comes the next definition here, which is isobars. Again, iso refers to as same. So what is going to be same in this situation? It is just opposite to that of isotopes. But here we are considering different elements. In isotopes, we took same elements, but in isobars, we are taking different elements. So all I would say that atoms of different element which have same mass number, that is the capital A, I am directly writing it, but different atomic number, that is capital Z. So examples of this we can take is of argon, potassium and calcium. All of these have same mass number, that is 40, while their atomic numbers are different. For argon it's 18, for potassium it's 19 and for calcium it's 20, right? So in all of these cases you can see 40 is their common and it is referred to as mass number because it is written at the top of the element, and while we can see atomic numbers are 18, 19 and 20 which are different in 3 of the cases, right? So these are refers to as isobars. Now students, comes the third definition, which is known as isotones. What are isotones? Isotones. Students, isotones are those species in which the compounds, in which the elements basically have same number of neutrons. Atoms in which same number of neutrons are present. Neutrons are present. The rest of the thing you will see are different, students. One of the example is carbon and nitrogen. I would take, so if I talk about carbon, its atomic number is 6, and if I talk about nitrogen, its atomic number is 7. If I take for carbon, its mass number is 12, and if I take of nitrogen, its mass number is 15. Now we need to calculate the number of neutrons in both of these cases, right? If I take about the number of neutrons in both of these cases, I would take here the isotope of carbon, which is carbon 14. Just like we saw, isotopes are those elements which have same atomic number while different mass number. Similarly, carbon also exists in the form of isotopes. So I am taking the element of that carbon, which is the isotope. So carbon 14 isotope and nitrogen 15 I am taking along with this. Along with this, you can take of oxygen also as well. Okay, if I take off oxygen, this is the case for oxygen. So now you can see that 14 minus 6, I would take it is 8. 15 minus 7 is 8. 16 minus 8 is 8. Right? So number of neutrons, that means mass number minus atomic number is neutrons, right? According to the formula which we did previous. So we could say that in all these cases, neutrons are equal. Again, I'm telling you why I have taken isotope carbon 14 and why I have not taken carbon 12, because carbon can exist in both of the forms. So because carbon 14 is isotone to nitrogen 15. That's why I have taken this example. Okay, now proceeding towards the next category, that is isoelectronic, students. Isoelectronics are the species which contain same electrons, same number of electrons, right? Okay, isoelectronics refers to as same number of electrons. Same number of electrons. Basically, example that we could take is of Na positive, Mg plus 2, Al plus 3. Right? So these are the examples for the isoelectronic species. All of these three contain 10 electrons, right? So students, these were the cases for the iso, isobar, isotone, isoelectronics, and so on. So now moving towards our next topic, all I would say is that there is one question for you. You need to find out mass number, atomic number, protons, electrons, and neutrons, right? So students, first of all, we are taking the case for oxygen. See, for this oxygen, it is already given to us about the protons, right? For protons, I would say number of protons for any neutral species, like it's given oxygen. For neutral species, number of protons is always equal to atomic number, right? So all I would say is atomic number is also going to be 8 in this case. The next thing that we always should remember is mass number is equal to number of protons plus number of neutrons. This is the formula, right? And here in the first case, we have atomic number, which is number of protons, and we have neutrons also with us. So with the help of neutrons and protons, we can calculate mass number. That means if I add protons and neutrons, I'm going to get the mass number, and it is going to be 16 now. So for this case, the answer is 16. Now, number of electrons are being asked, and oxygen is written alone. That means it is a neutral species. It doesn't have charge on it. So hence we can say that number of electrons will be equal to what? Number of electrons will be equal to number of protons for a neutral species. So here answer will be again 8, right? So this was all about oxygen. Now the next part here is about sodium ion. Students, if I talk about sodium ion refers to as Na positive. Okay, and if I talk about sodium ion, all I would say is that here it is given to us that mass number is 23, protons is 11, rest of the things we need to find out. You know that number of protons is equal to atomic number, so we can say that protons are 11, then atomic number is also 11. Right? Now the next case arises as number of neutrons. How to calculate number of neutrons? According to our initial formula, this one. Mass number is equals to neutrons plus protons. Mass number we have here is 23. Neutrons we need to calculate and protons we know it's 11. So 11 will be subtracted now and we'll get neutrons which is going to be 12. So neutrons for the case of sodium ion we are getting is 12, right students? Okay. Now the next thing which arises in our mind is number of electrons, students. See, for a neutral species, number of electrons is equal to number of protons. But what happens is, here they have asked us about sodium ion, that is Na positive. And I already told you that if something positive is given to you, you need to subtract it. If something negative is given to you, you need to add in it. So here you can see that students, for sodium ion, I would say electrons is coming out to be 10. Why it is coming out to be 10? Because number of protons is number of electrons. That means 11 it should have been if it was neutral. But Na positive. That means we need to subtract one number because it's given positive. So number of electrons comes out to be 10. Right? Now comes the next case. That is bromine. Again we have been given number of electrons and neutrons, and bromine is written simply. That means it is a neutral species. So number of electrons will be equal to number of protons. So all I would say is, if 35 is number of electrons, then protons are going to be same. And if protons is 35, then atomic number is also 35, right? Okay. So the last thing that we need to find out here is mass number. Mass number is what? Mass number is the sum total of number of neutrons plus number of protons. So it is 35, that is our protons, and neutrons are 45. So when we add them, it is going to be 80. So we would say that mass number for bromine is going to be 80, right? So this was the complete table that we have concluded for electrons, protons, mass number and atomic number, right? Okay. So now students, I am going to proceed towards the dual nature of light. Why there is requirement for dual nature of light? Why we need to study about the dual nature of light? Basically what happened, at last we studied about Rutherford model of atom. It had some limitations, students. It had some limitations that it couldn't explain about the stability, you know. It could not explain us about the stability. Hence, we need to move forward towards our next explanation, which could tell more about atom, which could explain more about atom. Rutherford model of atom also couldn't explain about hydrogen spectrum, which in further cases we would see that they are explaining. So there arise the dual nature of light. Basically what happened, light has dual nature. Dual refers to two natures, right? Students, one is wave nature. One is wave nature. And the other one is the particle nature. The other one is the particle nature. What is the basic difference between wave nature and particle nature that the light exhibits? See, wave nature refers to as when the light travels in the form of wave, you know, and particle nature refers to as when the light travels in the form of small energy packets known as quanta. So this is the basic difference between wave nature and the particle nature. Now in the form of wave, light travels in the form of electromagnetic wave. Okay? Light travels in the form of electromagnetic wave. Now what are the characteristics for electromagnetic wave? Basically electromagnetic wave shows two basic components. One is going to be electric field, another is going to be magnetic field, or I would say electrical component or magnetic component. Now to represent this, see, if this is my direction of propagation of light, if this is my direction of propagation of light, then both of the components of electromagnetic wave, that is electrical component and magnetic component, both will be perpendicular to the direction of propagation of light. And if both will be perpendicular to the direction of propagation of light, let us say that this is our electrical component, right? and this is our magnetic component. So these both are, these both are at a 90-degree angle to the direction of propagation of light. Which this is magnetic component and the other one is, students, electric component. So what does we conclude here? That we conclude that light, travels in the form of electromagnetic wave, which have the two following basic components: electrical component, magnetic component, which both are, perpendicular to the direction of propagation of light. Right, students? Okay, so here we get that energy is equals to h mu. This is the basic formula that we see here, that light travels in the form of this direction. Right, now comes the particle nature. As I told you, what is the particle nature? In particle nature, we see that light doesn't travel in the form of wave. Here it travels in the form of small pockets. Now these small pockets are filled of energy, which are known as quanta. Light here travels in the form of quanta. Now what are quanta? These are the small packets of energy. Small packets of energy. Now students, proceeding towards the wave nature, we are going to discuss more about wave. What is a wave? How does a wave move? What are the basic characteristics a wave could hold? So in front of you, I have drawn a wave, right? This wave have particular crust as well as trough. Now what is this crust and trough? Basically, you will observe that a wave travels like this. Right, as I already made electrical component and magnetic component. So you can see here, this is the height for a particular crust, or this is a height for a particular trough. This is a height for a particular crust. This is a height for a particular trough. Now what is the height from the direction of propagation to the crust and trough? It is referred to as amplitude. Right, so the first thing that we need to know about a wave is its wavelength. What is a wavelength? If I talk about wavelength, okay, if I talk about wavelength, wavelength is basically the distance between two consecutive crust or troughs, right? It is the distance between two consecutive crust or trough. Right, you can observe here, from the centermost position of the crust to the centermost position of the crust. Crust is basically the upper portion, trough is basically the lower portion. So this is basically refers to as wavelength, which is represented by lambda. Right, okay. The next basic term which we need to know is about frequency. Here you can already mention here, the second one is frequency. Now student, what do you mean by frequency? The number of waves that pass in 1 second, right? For example, it is like this. This is referred to as wavelength, right? And now if I'm talking about frequency, frequency is number of waves that passes in 1 second. Right, students, the very next thing, you should know here in frequency is its unit. Unit here, it's hertz. Hertz is the unit for frequency, or cycle per second. Or cycle per second. Right, students? Now next comes the wave number. Students, wave number is also represented as like this. nu bar. It refers to as number of waves that could pass in a unit cycle. Number of waves in unit cycle. Okay. Is it clear to you, students? Even you can write a formula considering wavelength and wave number. That is, if I talk about wavelength, it is equals to 1 by nu bar. Okay. Or if you talk about wave number is 1 by lambda. Right? So this is the basic formula that you should already know, students. And other than this, if I talk about this amplitude, already I have told you amplitude is the height from the direction of propagation of light to the highest peak, that is crust, or the lowest peak, that is trough. Height of the crust or height of the trough is basically referred to as amplitude. All you can say is here, right? I'll write it here only. Height of crust or trough. So yes, students, this was all about wave. Now we'll proceed towards our next topic, that is going to be the Planck's theory or theory of quantization, which I've already told you. That is the particle nature. I have told you that particle nature basically comprises when our light travels in the form of small packets called quanta. They have already explained this in Planck's theory. What is that? According to this theory, energy cannot be absorbed or released continuously, but it is emitted or released in the form of small packets, which are known as quanta, right? In the case of light, this quanta is known as photon. For the case of light, we call it as photon, right? Okay, this photon travels with the speed of light. Energy of photon is directly proportional to frequency. Hence, again, this formula is very important, that energy is equals to h nu, where h refers to as Planck's constant. H is Planck's constant, and whose value is basically 6.62 into 10 raised to the power minus 34 joules second. So you need to remember the Planck's constant value as well as the particle nature theory, which is also known as Planck's theory or theory of quantization, that light travels in the form of quanta known as photons. Clear, students? Okay. Now we'll proceed towards our next topic. So yes, my dear students, now we are going to start our next topic, that is going to be Bohr's model of atom. Basically, Bohr gave some postulates in which he told about the electron. That electron revolves around the nucleus in a limited circular path. What happens is, if I consider this as my nuclei, then so many circular paths are present in such a way around the nucleus. And electrons revolve in this circular path, right? So what happens is, this key point should be marked as an important, right, that they revolve only in limited circular path, and he assumed that electron does not radiate energy during its revolution. When it's moving, it does not radiate energy. It radiates only energy when it is moving from higher energy level to lower energy level. What happens is, students, there are two cases. One is the case when electron jumps from lower energy to higher energy, and the second case is when it jumps from higher energy to lower energy. So when electron moves from lower energy level to higher energy level, it gains energy and so move upwards, while when it moves from higher energy level to lower energy level, it radiates its energy. So when it is revolving, it doesn't radiates any energy. So these 3 points are most important, that electron does not radiate energy during its revolution in the permitted paths, right? And this point which I have told you just right now, the 5th point, is most important, because here it is telling us that when electron absorbs energy, then it jumps to higher orbit from the lower orbit, right? And when it comes back, it radiates energy. When it comes from upper portion to lower portion, it will radiate, and when it will go from lower portion to upper portion, it will absorb energy, right? So these postulate explains all about spectra. How do these explain about spectra? Look into the figure which I am making right now. I am telling you that there are some energy levels, right? So our electron is present here. right? And if it is moving from this energy level to the higher energy level, it needs some energy. Whenever it reaches at the top at the higher energy level, it will come back to its initial position. So while coming to its initial position, it will release some amount of energy. So these all things explain us about spectral lines, right? Okay, other than this, what we got from the Bohr's model of atom, we achieved that those orbits are allowed whose orbital angular momentum is integral multiple of h by 2 pi. It means us to state that the electrons which are moving from lower energy to higher or from higher to lower basically have an angular momentum which is an integral multiple, okay, about h by 2 pi, where n can be 1, 2, 3, 4 depending upon the number of shell. Right? Okay. Students, now Bohr model of atom also gave us a lot of information about radius, velocity, total energy. So what is the mathematical treatment of Bohr model of atom? We have this formula for radius. Now here, basically Z stands for the atomic number. Whosoever atom is given to you, you need to write Z as its atomic number. And yes, Bohr model of atom is only valid for single electron species. Please do keep note in your mind, right? Other than this, students, what you have to see is, if I give you a case, if I consider a case where I have, one second. One second, students. So I am taking a case where there are two shells present, right? This is my nuclei. This pink one is my first shell. This yellow one is my second shell, right? So in this case, students, if I ask you to find the relationship between the radius for both of the shells, for example, what I'm saying, the distance from the nucleus to the shell, this is R1 because it is the first shell, and the distance from the nucleus to the next shell is R2, right, for the second shell. This pink one I am again saying is my shell number first, that is n is equals to 1, while this yellow one is n is equals to 2. So if I ask you for a single atom, for the same atom, what would be the relationship for different shells? If you have this as your formula, so what would you do is, you will put your values, right, Z for a same element. For example, if I am talking about hydrogen, Z will be same, right? So this is for same element, kindly write that. This is for same element, to find or to establish a relationship between the radius. So what I will say is, R1 for your first shell is equals to 0.529. Now n square here, n is your basically shell number, right students? N is your shell number, so let us write it as n1 square. Okay, now divided by Z. Z is common for both the cases because it is the same element. For example, it is hydrogen, then Z will be 1. If it is helium, then Z will be 2. For that case, I am telling you, right? But do remember, Bohr model of atom is valid for single electron species only. Now, if I talk about R2, what will be the formula? 0.529. Now, N2 square divided by Z. Again, Z is same because it is for same element, right? Now, if I say divide both of them, this is cut, this is cut. What the relation I am getting is R1 by R2 is equals to N1 by N2 whole square, right? So this is the basic relationship which I establish when I am taking a same element, when I am considering same element, students. But for example, students, for example, if two different elements are present and we need to establish the relationship between their radius, so what would be the relationship? Now write it down, please. If we consider for different elements, what will be the relationship, students? Okay, now for different elements, let us make diagrams first. For example, this is my, first one, and this is the structure for the second one. Okay, now this is nucleus and this is the first shell, while this is nucleus and this is the first shell for the another element. If I am considering this is A element and this is the B element, okay, this is your N value, right? Let us say it is N1 and it is N2, right? And let us say that this is R1 and for this it is r2. Distance from the center to the outermost position is radius, right? So now I have to establish the relationship between two different elements now. So I have to write the formula. R1 is equals to 0.529. Now n1 square by Z1. Now the Z for both the cases will be different. Why it is different? Because the elements are different. If the elements are same, then the atomic number is same. But if the elements are different, then the atomic number is as well as different. So similarly for R2 I can write 0.529 N2 square by Z2. Now if I say dividing both of these situations, if I divide both of them, R1 by R2, what I will get is, first of all I am writing R1 0.529 N1 square by Z1. Now, if I am dividing it by R2, I am going to write 0.529 N2 square and Z2 will move upwards. Now, 0.529 is cut by 0.529. What is the relationship? R1 by R2 is equals to N1 by N2 whole square into Z2 by Z1. Now, this is the relationship, students, that we get when two different, elements are taken. When two different elements are taken, this is the relationship that is being established, right? But for the same element, this is the formula that we are going to use. Now, for the sake of questions, these two formulas are the most important. But this formula, if you remember this formula, then you can easily derive any of the formulas. So if you forget in your examination, just do remember the simple basic formula so that you can apply on and you can elaborate and establish your relationship at that spot, on the spot, right? So now moving towards the next formula, that is the velocity of the moving electron. As I told you, Bohr model of atom gave information about radius, velocity, total energy. So this formula for velocity is very, very important, students. You need to mark it. It is 2.19 into 10 raised to the power 8 Z by n centimeter per second. Other than this, students, the most important formula is for total energy. But I have shown you all the formulas. Do remember that kinetic energy is negative of total energy. Here E stands for total energy, right? So if you find total energy, just negative of it is kinetic energy. And the very most important formula, students, is this one. For total energy, the most important formula is this one, minus 13.6 Z square by N square electron volt per atom. And on the basis of this, students, on the basis of this, just like radius, we will establish two more relationships for the same element and for the different elements. But below this formula is the total energy formula, which is given to you in kilojoule per mole. This is given you in electron volt per atom. This is given in kilojoule per mole. And this is the energy formula given to you in kilocalorie per mole. Clear, students? So now I am going to establish a relationship with the help of this formula. That means in electron volt per atom for different cases. If I consider case 1, when same element is given to you. For example, when same element is given to you, then this is going to be your R1 and this is going to be R2. R1 here, this is N is equals to 1 and this is our N2, right? It's the second shell. Now to establish the relationship for the energy, if I say for the first shell, E1 will be equal to minus 13.6. Now here Z, if it is for the same element, Z is going to be remaining same. So Z will be same, that is Z square divided by, what will be the N here now? N1 square. And if I talk about the energy level for the second shell, it is going to be minus 13.6 Z square divided by N2 square, right? So if I divide both of these, E1 by E2 is going to be minus 13.6 Z square by N1 square into minus 13.6 Z square divided by N2 square. So this whole is cut by this whole, and so we will establish a relationship, that is E1 by E2 is equals to N2 by N1 whole square. This is the formula for your energy, students, for your total energy and your shell. So you can directly put the formula in your examination. It is also very, very important. Clear? Other than this, students, what they can ask you? They can ask you all about when different elements are given. That is your case number 2. Okay, now for case number 2, when you have been given different elements, like this is your first element and if I say this is your next element, second element. So for this, it is going to be R1 and this is your N1, and for this it is going to be your R2 and this is your shell N2. For this Z is equals to Z1, for this Z is equals to Z2, because these are different, elements. Now to establish relationship between them, again I'm going to write E1 is equals to minus 13.6 Z square. Now Z1 square by, Z1 square by N1 square, and for E2 you are going to write minus 13.6 Z2 square by N2 square. If we divide both of these, students, we are going to get E1 by E2 is equals to Z1 by Z2 whole square, right? You are going to get the same situation, yes, into N2 by N1 whole square. Now this is the relationship that you establish for two different elements. Okay, just like radius we have done this, and it is also important. So kindly put a star mark here as well. Now you need to remember two cases in the case of this as well as in the radius. This was about the Bohr's model of atom, which stated us about the total energy also. Now students, comes our next topic, that is the photoelectric effect. Photoelectric effect, what does it tells us? See, basically what happens is, whenever a photon, okay, photon may be like the particle of light which we incident on a metal surface. Now these photon is incident over this metal surface, which leads towards the release of an electron from the surface, is known as photoelectric effect. Now what is photoelectric effect? You can see with the help of diagram. This is your metal surface. You are incidenting a light, a photon over the surface, which releases electrons and is detected here, This process is known as photoelectric effect. Okay, so here we need to know is that this is the equipment for studying the photoelectric effect. You can see that. Other than this, students, there is a basic formula for photoelectric effect which we need to know is that there are two basic things which we need to remember is that kinetic energy is released and work function is required. Work function is required to release electron from the metal surface. Now what happens is, students, we are inciding a photon, right? So all I would say is the energy for the photon that is being incident on the metal surface is h nu. It will be equal to h nu naught. H nu naught here refers to the work function. That means how much energy is required for that electron to emit out from the metal surface. Basically, that is that energy which is required. See, one is the energy which we are supplying on the metal surface so that electron can be emitted. Another one is the energy that is being supplied so that electron comes out. And after that, some energy is left out, which is known as kinetic energy. Energy other than the work function which is left out, right? So that is our kinetic energy. Now this is incident photons energy. This is the energy basically required by the electron to come out, or I can say work function. Work function here refers to the work that is done on the electron to come out, right? And this is the kinetic energy which is released. So this is the basic formula that you are going to apply on all the questions for the case of photoelectric effect. Right, students? Okay. Now coming towards our next topic in photoelectric effect is stopping potential. What do you refer by stopping potential? Basically, as I told you, we are giving some energy. We are giving a photon of some wavelength, right? And the electron is being emitted out. So what voltage should I apply so that electron stops and doesn't emit out? See, I have given some energy so that electron could emit out. But what voltage should I apply on that so that electron stops? So that energy, that voltage is known as stopping potential. Now see, the minimum potential applied by which velocity of ejected electron, the electron which is being ejected out, becomes zero. The velocity of that ejected electron becomes zero is known as stopping potential. Is known as stopping potential. Half mv square is the kinetic energy, so don't get confused. Kinetic energy's formula is half mv square, right? Here you have this vs, which is stopping potential, which you are applying on that electron, on the ejected electron, and E is basically the charge on electron. Here EVS is referred to as the work done to stop the electron, to stop the ejected electron from moving. Clear? This EVS refers to as the work done to stop the electron that is being ejected. That is known as stopping potential. Clear, students? So this was about photoelectric effect. Now comes all about spectra. Now what do you mean by spectra? See, to understand spectra, I would say that the record of the intensity, all the recordings that we do of the intensity transmitted or scattered by a molecule as a function of frequency or wavelength, in any of the terms you can say, is called its spectrum. For example, if I talk about hydrogen spectrum, what do? We take in the case of discovery of electron, we took Crookes tube, right? Similarly, in that Crookes tube, we have put in hydrogen gas. So when we put hydrogen gas and we apply some energy, we apply high voltage in it, what do we observe? We observe that hydrogen molecule gets split into its particularly atom, hydrogen atom. Now these hydrogen atom basically have different wavelength, have different series of wavelength, and when we record these wavelength, we observe a spectra. Now what happens is, as I already told you, there are some these energy levels. When an electron moves from lower energy level to higher energy level, it requires some energy, and when it comes from higher energy level to the lower energy level, it releases some energy. So during this process, what we do? We observe some spectral lines. So in the case of hydrogen spectra, we observe different spectral lines, as you can see through the following diagram. What happens is, students, these are the energy levels, like this is n is equals to 1, 2, 3, 4, 5, 6, 7, 8. That means what it is, I'm going to explain you one by one. Look, if I say my electron is moving from n is equals to 1 to n is equals to 8. Kindly understand this. If my electron is going from the ground level, like these are energy levels, right? I would say my electron is present here. It is going from here to the upper levels, and the electron which is going from n is equals to 1 will automatically come to n is equals to 1. The electron which is going from n is equals to 2 will automatically come back to n is equals to 2. The electron which is going from n is equals to 3 level will come back to 3 level only. So what do you observe here is, like, these which are coming back are coming to which series? Are coming to n is equals to 1. That means the electrons were emitted from n is equals to 1 and will come back to n is equals to 1. So those electrons which come back to the ground level, at the ground level when n is equals to 1, that series are known as Lyman series, students, and it lies under the region of ultraviolet region. It lies under ultraviolet region. Now similarly, look at the Balmer series. Balmer series are those series when the electron come back to which position? Come back to n is equals to 2. That means the electrons once moved from n is equals to 2 to the upper levels, then again it can come back to which level? N is equals to 2. So that series is known as what? It is known as Balmer series, and it lies under the visible region. It lies under the visible region. Now students, if I look to the next series, that is Paschen series. Paschen series is that series in which our electron comes back to which position? N is equals to 3. And here it lies under infrared region. It lies under infrared region. Okay, if I talk about next series, that is bracket series, it refers to whenever electron comes back to n is equals to 4. Here also it lies under infrared region. Right, students? Okay, now comes the next series, students, that is known as P-Fund series, when electron comes over, which electron comes over n is equals to 5, students. So that is known as P-Fund series, and it also lies under infrared region. Clear? If I talk about Humphrey series, when n is equals to 6, when electron comes over n is equals to 6, it lies under our infrared region. Clear, students? But I would say infrared is the region from Paschen series to P fund. So it is far infrared region. Kindly correct it. It is far infrared region. So these are the series which are obtained in the case of hydrogen spectrum. Clear, students? So there are two basic formulas that you need to remember here. What are these? These are the number of possible lines produced when an electron jumps from nth level to first order. From any of the nth to first order, students, what do we, first orbit, what do we get? N bracket starts n minus 1 by 2. You can be asked one of the questions from this formula. Other than this, possible lines produced when an electron jumps from N2 to N1. N2 here refers to the upper higher level and N1 refers to the upper lower level, right? And the formula is going to be half into N2 minus N1, N2 minus N1 plus 1. This will tell you the possible lines that are produced when electron jumps. Like these are the possible lines that are being producing now. So these helps us to know that whichsoever be the orbit, we can directly put N2 will be the higher orbital and N1 will be the lower orbital, which is being asked you in the question, right? Other than this, students, one is the basic formula which you will require most of the time. That is 1 by lambda is equals to, now lambda here stands for wavelength, is equals to wave number is equals to Rydberg's constant, which is represented by R, into Z square. Now here Z stands for your atomic number. Now students, brackets start 1 by N1 square minus 1 by N2 square. This basic formula is most important formula and you can be asked a lot of questions from this formula. So kindly mark it as important, right? Kindly mark this as the most important formula. Here they can ask you the relationship between wavelength. They can ask you the relationship between the different shells, like N1 is the lower energy level, N2 is the higher energy level, R is the Rydberg's constant, Z is our atomic number. Right? Okay, students. Now comes the limitation of Bohr model of atom. What was the limitation of Bohr model of atom? Number one was Zeeman effect. It could not explain Zeeman effect. Next is, it could not explain Stark effect. It could not tell us about the dual nature of matter. About Heisenberg uncertainty principle. So these were the limitations of Bohr models of atom, students. Now comes, what do you mean by Zeeman effect and Stark effect, which were not explained by Bohr model of atom. So Zeeman effect was the effect when magnetic field was applied and spectral lines were obtained. Okay, when magnetic field were applied and spectral lines are observed, that is known as Zeeman effect. When electric field is applied and spectral lines are observed, that is known as Stark effect. So I would write the definitions for both of these. Zeeman effect is when magnetic field is applied and spectral lines are obtained. That is Zeeman effect. Okay, Stark effect is when electric field is applied, right, and spectral lines are obtained. Right? Okay. Now, students, coming towards our next topic, that is going to be Heisenberg's uncertainty principle. As you all know, Bohr's model couldn't explain this. Uncertainty refers to something which is not certain, which is different, which we cannot calculate. So, uncertainty principle told us that it is impossible to measure simultaneously. That means at the same time. Okay, the exact position and the exact momentum of a microscopic particle. For any microscopic particle, it was very tough. So, what was the uncertainty seen? Uncertainty in position. Uncertainty in position was known as delta x. Uncertainty in momentum was delta p. So how to calculate the uncertainty, students? I would say that uncertainty in measurements is equal to basically delta x. That means uncertainty in position into uncertainty in momentum, delta x into delta p. Then comes more sign or equal to h by 4 pi, students. Now this is the uncertainty formula for measurements. Clear? So this determines the uncertainty. That is that when we are unable to calculate the exact position and momentum for any microscopic particles. Clear, students? Now we are moving to the most interesting topic, that is the shapes of orbitals. So students, probability of electron is responsible for the shape of an orbital. If I consider the very first orbital, that is the s orbital, I would say that s orbitals are spherical in shape. Why they are spherical in shape? Because the probability of finding the electrons occur in a sphere-like structure. Hence, they are referred to as spherical in shape. Let us see with the help of a diagram. So if I talk about s orbital, these are non-directional, students. First of all, you can note this down also. Now, the next thing which we observe is that basically there are three axes, x-axis, y-axis and z-axis. If I draw them, this is my x-axis, right? This is going to be the y-axis and it is going to be the z-axis. So, here the origin, this is known as origin from where these axes arises, right? So, this origin in the case of atom is referred to as nuclei. This is nuclei or nucleus. Right, students? So, what do we observe here? We observe that, students, we observe that the electrons that are found in s orbitals are found to occur in this portion. And they form a sphere-like structure. Hence, the probability of electron here is determining that s orbital is spherical in nature. Right? It is spherical. Other than this, students, what we need to understand here is that basically s subshell contains one orbital only and a single orbital contains two electrons. So we can write that s subshell contains one orbital, right? And one orbital can have maximum 2 electrons. How does it look like, students? This is the one orbital, right? And I always told you that they have 2 electrons in this. One orbital can have maximum of 2 electrons. How to represent these electrons? One of the electrons is represented in this direction like this and the other one in this direction. This you are going to cover how these electrons are represented in the quantum numbers topic, right? So, this is the representation for 2 electrons in one orbital. Hence, we conclude that s orbital has only 2 electrons, right? Now, coming towards our next, that is p orbital, students. Okay. Now, coming towards the next category, that is about p orbitals. Okay. If I talk about p orbital, then what is the shape for p orbital? P orbitals are dumbbell shape. P orbitals are dumbbell shaped. If I talk about p orbitals, basically what we observe that p orbitals are dumbbell shape, hence to represent them, again I am taking three axes. This is my x-axis, this is my y-axis, and this is z-axis. See students, like I told you in s orbital that there is only one s orbital found in s subshell. If I talk about p subshell, how many orbitals are there seen? There are total 3 orbitals seen in the case of p subshell. See, whenever I am trying to say you that subshell contains orbitals and orbitals contain electrons, this is the basic address for an electron. How to find an electron? To find an electron, we need to understand that where it is situated. First of all the subshells, see, first you need to see that shell has subshells under them. Subshells have orbitals under them. And orbitals, students, contain electrons. This is the basic address to find an electron. If you're going to find me where do I live, you need to find first of all the country, then you need to find the state, then you need to find all the city, then you need to find the basic address of my hometown. So this is the basic region you go for to find a particular person. Similarly, to find an electron, we require these 4 necessity conditions. First of all, we need to see which shell it is. Then we need to find out what subshell it is. I am talking about p subshell. Then under p subshell, what I am going to see? I am going to see the orbitals. So under p subshell, basically there are 3 orbitals, right? In case of s or in case of s subshell, how many orbitals are there? 1 orbital is there, right? And after that orbital, we are considering electrons. Like in s subshell, we saw 1 orbital. In that 1 orbital, we saw 2 electrons. Similarly, in p subshell, we see 3 orbitals. Which are these 3 orbitals? These are px, py, and pz, students. These are the 3 orbitals, which are found under p subshells. Now, these 3 orbitals will contain how many electrons? I already told you that 1 orbital can contain maximum of 2 electrons. So, 3 orbital will contain how many electrons? Total 6 electrons. Total 6 electrons are observed or seen, right? Now, kindly put this in a box so that you can remember it always. Now, students, to represent all of these px, py, and pz, we always need to remember the axis. This is the x-axis, this is the y-axis, and this is the z-axis. To represent px now, what I'm going to see that the lobes are found on the x-axis. The lobes are found on the x-axis like this. Now, what are these lobes? See, as I told you, s orbital is spherical in shape, so it forms a sphere. But p orbitals are dumbbell shape. How does a dumbbell look? A dumbbell looks like this. Okay. Now, one dumbbell contains 2 lobes. This is half lobe. This is known as 1 lobe, I would say. Not half lobe. It is 1 lobe. Okay, so I'm joining it with another lobe. How many lobes are present? This is also 1 lobe. So, one dumbbell contains 2 lobes. Do remember that. Now, if I am making a dumbbell shaped p orbital on the x-axis, it is referred to as px orbital. If I am making, now let us make on the y-axis after that. Okay, now let us make the same structure on y-axis. See, this is my x-axis. This is y-axis, again this is z-axis, right? If I represent these 2 lobes on the y-axis, this is my y-axis on the upper end and this is on the lower end, right? So this will be known as which orbital? Py orbital. Py orbital. Students, why I am shading this area? I am shading this area to let you know that electrons are found in this region. The probability of finding electron is responsible to determine the shape. Here the electrons were present in the spherical region, hence they formed a sphere-like structure, right? Here they are present in such area and they are forming a dumbbell shape-like structure. So the probability of electron where they are found are responsible for the shape of an orbital, right? Other than Py, which one is the third orbital? Pz is the orbital. So, how will you make pz? It is very simple, students. First of all, you need to draw the axis, x-axis, y-axis and z-axis. If I talk about pz, Then the lobes will be find on which axis? Z axis. If you get confused, kindly extend the axis in such a way and draw like this. Right? So this is my Z axis. Hence, I would say that this is my pz orbital. Clear? Okay. Okay. Now, as I have made this diagram, made this one orbital and represented electrons in this. Now, how to represent electrons in the case of p orbitals? I told you basically there are 3 orbitals. So, how we are going to make it? 1, 2 and 3. These are the 3 orbitals, right? Which are px, py and pz, right? Now, to represent the electrons, we know that each orbital contains maximum of 2 electrons. So it will be 1 first of all. Okay. Now this is the basic representation for the p orbital's electron, right? Hopefully you have understood s orbital and p orbital. Now students, we are moving forward towards the d orbital. Now as p orbitals were dumbbell shape, d orbitals are double dumbbell shape. These are double shaped orbitals. As I told you, p subshell contains 3 orbitals. Similarly, d subshell contains 5 orbitals. Okay, do remember that? D subshell contains 5 orbitals. Now, as I told you, a single orbital can contain maximum 2 electrons. So 5 orbital will contain how many electrons, students? It will contain 10 electrons. So this is going to be very important. Total number of electrons are going to be 10 in this case, right? Because individual orbital has maximum of 2 electrons. How to represent them, students? How to represent them? We need to make 5 orbitals like this way. Now to represent electrons, again I'm going to explain you in the similar way. This is my upper spin, this is my lower spin. I'm going to tell you what is their role. One is anti-clockwise, another one is clockwise, which we are going to study under the spin quantum numbers. So don't get confused. We are going to learn how to represent these electrons, how to fill these electrons in the orbital in the coming topics also. Right, students? Now, if I talk about these, orbitals, what are their name? Likewise, in P, we understood that Px, Py and Pz were the 3 orbitals under P subshell. Now, under D subshell, what are the names of the orbitals? Their name is dxy, dyz, dzx, then is dx square, y square, and last one is dz square. Now one by one we are going to represent all of these. First of all, we need to understand that d orbitals are classified into 2 basic categories. One is the axial one, another one is the non-axial one. Okay, you need to understand this, that d orbitals are classified into 2 basic subcategories, that is the axial one and other one is the non-axial one. Now, as the name suggests, axial refers to as those orbitals that are found on the axis, while non-axial ones are the ones that are not found on the axis but in between the axis, right? So if I talk about the axial one which are found on the axis, these are two. Which one? These are dx square y square and dz square. And if I talk about non-axial one, students, these are dxy, dyz and dxz. Now we are going to represent all of these. First of all, I am going to make the non-axial ones, right? First of all, I am going to make you the non-axial ones. Okay, here I am drawing the non-axial orbitals. So number first is dxy. To represent dxy, first we need to understand xy represents what? Xy represents that when you are making your lobes, they are present on the x-axis and y-axis, not on the axis, in between the x and y-axis. Why I am saying in between? Because these are non-axial. Axial will be the one that are present on the axis, while non-axial will be the one that will be present in between the axis. Now, in between which axis? In between x-axis and in between y-axis. So, to make any of the structure, first of all, students represent the axis. Now, I am representing this as my x-axis, this as my y-axis, and this as my z-axis, right? This is the basic thing that I am making. Now, I will extend these lines in such a way, you know, the mathematics which we follow, if it is x-axis, it is going to be minus x-axis, it is going to be y-axis, it is going to be minus y-axis. We do in such a situation, right? So I have to make my lobes in between the axis because it is non-axial. And we know that d orbitals are now basically what? Double dumbbell. That we need to make now how many lobes, students? Total 4 lobes will be made, right? A single dumbbell contains 2 lobes, and now 2 dumbbells will contain 4 lobes. Now to represent this here, look at the structure. It is like this. These are present in between the axes. These are present in between the axes. Why I am again shading them? Because the probability of finding the electrons are present in these regions, which make them double dumbbell shape, right? Now this is referred to as dxy because it is present in between x and the y axis. Now coming towards the next category, that is our dyz. Now look into the dyz category. Now I am taking y-axis now here and z-axis here. You can take y-axis here and z-axis here. It is according to your comfortability. Now you will say that, ma'am, no, it is referred to as x-axis, but you are taking y-axis. It is the representation. If you are taking x-axis in this direction, students, then you don't have to put your lobes on that axis. Remember that. If you are taking this as y-axis, consider this at y-axis. But if it is not given anything anytime, that you have to consider this as your x-axis, this as your y-axis, and this as your z-axis, which we consider as a standard reference. But to represent it in your sheet, or I would say in your slides, I would say you would directly write this as y, this as z, which you want to draw. If you want this as to your x, this as to your z, this is to your y, just write there, so that the person could understand that you are considering this as your y-axis. Okay, and if it is not mentioned, kindly take it as x-axis. Now coming towards this, we need to make lobes here. Now as you know, the lobes in between y and z, so in between y and z, in between y and z, by just changing the axis name, the orbitals are changed. Here x and y are present, here y and z are present, so this is y, dyz. The last one here, I would say, is dxz. I am taking this as my x-axis, now this as my z-axis. So again, my lobes will be present in between them because these are non-axial, right, students? I am shading this because it is representing us the probability of electrons, which is making a double dumbbell shape. See, this is a single dumbbell. The double dumbbell will contain 4 lobes basically. Clear, students? Now these were the non-axial ones. If I talk about the axial ones, these are very interesting, and it is going to be very interesting topic. So let us write it now. The axial ones. Axial ones are the orbitals which we see that lobes are drawn on the axis. Now how? See, the first case is dx square y square. To represent dx square y square, we can see that 2 axes are found there, x-axis as well as y-axis. Now I am again drawing them. This is my x-axis, this is my y-axis. Now I have to make the lobes on the axis. If I make the lobes in between the axis, it will come under the category of non-axial. But when I am making it on the axis, it will come under the category of axial orbitals. So how to represent this one? See. Okay, now this is the basic structure, students, for dx square y square. You can see that now the lobes are present on the axis. Now they are present on the axis, students. Clear? So this is the structure for dx square y square. Now the last one, that is the dz square. Okay, now this is my z-axis. Now please carefully see this. dz square is like this. One lobe is present on the z-axis and the other one forms a ring around it. Other one forms a ring around it in such a way. This is my first, dumbbell shape orbital, and other one is present as a ring around this. So this is the structure for dz square, students. And it is referred to as what? Axial. Why it is referred to as axial? Because it is present on the axis. That's why. Now, these were the shapes of the orbitals, students. These were the shapes of the d orbitals. The basic three things that you need to remember is that it contained total 10 electrons. It have total 5 orbitals, which are these dxy, dyz, dzx, dx square, y square, dz square. So these are the basic things that you need to remember. Other than this, there is also an orbital which is known as f orbital, which further contains how many orbital? Which further contains 7 orbital, and hence contains how many electrons? 14 electrons. So students, now moving forward towards our next topic, that will be helping us towards to find the address of a particular electron, which is known as quantum numbers. Now, quantum numbers are a set of 4 numbers that determines the basic address to find the electron, right? So if I write the definition, it is the set of 4 which determines the address, shape, energy of an electron. It basically tells us where does an electron lives. For example, if you need to find me, you need to find the area where I live. Similarly, if you need to find the electron, you need to find where does it live. To find them, students, we need quantum numbers. Quantum numbers are going to help us for them. Right, students? Okay. So, one thing we need to understand them, that these 4 set, what are these 4 set? The number first is, okay, principal quantum number. Principal quantum number. Students, the second most is azimuthal quantum number. Azimuthal quantum number. The third one is magnetic quantum number. Magnetic quantum number. And the last one is spin quantum number. Spin quantum number. Right? So these are the basic 4 quantum numbers that will be going to help you to find about an electron, right? If I talk about, students, if I talk about the very first, that is known as the principal quantum number. Principal quantum number is represented by n, small n, and it is going to tell us about shells, information about it will be giving us information about shells. So one by one, what we need to remember is that we need to remember that to find any electron, we need to find first of all about shell, then we need to find about its subshell, Then we need to find about its orbital. And at the last, we need to find about the electron or electron spin. Right? Okay. If I talk about the very first, that comes out to be the principal quantum number. Principal quantum number. Students, principal quantum number is represented by small n. The next thing is that it explains us about shell, about radius, about distance, about velocity. Okay, so these all explain us about, about the small n, about the shell, about the radius, about the distance, about the velocity. So we find a lot of things about electrons. It also tells us about potential energy, total energy. We get to know all these things under this category. Potential energy, total energy, right? Now, how to see that what is the value of n? First of all, the first question arises in everyone's mind. What is the value of n, students? N represents number of shells. See, if I talk, this is the nucleus, right? This is my first shell, this is my second shell, this is my third shell, this is my fourth shell, right? So, if this is my first shell, this is my first shell, so here n is equals to 1. This is my second shell, so here n is equals to 2. This is my third shell, so n is equals to 3. This is my fourth shell, so n is equals to 4. When n is equals to 1, students, it is referred to as our K shell, right? It is referred to as our K shell. In bracket I am writing it. When n is equals to 2, it is refers to as L shell. When n is equals to 3, it is referred to as M shell. When n is equals to 4, it is referred to as N shell. So these are the values of shell which we see, right? Other than this, students, principal quantum number also explain about orbit angular momentum, right? It explains us about orbit angular momentum, which is nh by 2 pi. Now, there are two basic formulas which we need to remember is that how many electrons are present in a shell. The maximum number of electrons present in a shell is equals to 2n square. Okay, now let us find the maximum number of electrons in the particular shell. If I talk about the first shell, that is n is equals to 1. First shell, n is equals to 1. So what is the value of maximum number of electrons here? 2 into 1's square, that is going to be 2 electrons. Hence, we can say in the very first shell, how many electrons are present in the very first shell? Only 2 electrons are seen, right? Okay, now if I talk about when n value is 2, that is second shell. If I talk about second shell, when n is equals to 2, maximum number of electrons will be 2 into 2 square, that is going to be 2 into 4, it is going out to be 8 electrons. So now what we are observing is that in second shell, how many electrons are present? Total 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. Right, students? Okay. Now if I come across the third shell, if I talk about the next shell, that is going to be your third shell. How many electrons are present? N value is equals to 3, right? So the maximum number of electrons are going to be 2 into 3's square, that is 2 into 9, it is coming out to be 18 electrons. So what we will observe that the third shell is going to contain how many electrons? 18 electrons. Similarly, if I come across last one, that is the fourth shell, you can proceed further also. I am considering only 4 shells so that I could tell you how to calculate it, right? So if I talk about fourth shell, when n value is equals to 4, I would say the maximum number of electrons comes out to be 2 into 4's square, that is equals to 2 into 16, which comes out to be 32 electrons. Clear, students? Okay. Now this was all about the first quantum number, that was principal quantum number, which explained us about shell. That if n value is equals to 1, that is refers to as your first shell, which is around the nucleus. It is also known as K shell. If I talk about the second shell, it is present after the first shell and it is known as L shell. Then comes M shell, N shell, and further we have also calculated that a particular shell contains how many electrons? It contains 2n square. So you need to remember this basic formula. It is going to help you in many ways. Students, kindly mark this formula as your star and do not forget this. Do not forget this. Okay. Kindly put here a star so that you could remember this, right? Okay. Now moving towards our next category, that is going to be your azimuthal quantum number. The second one is going to be azimuthal quantum number. Okay. Now, azimuthal quantum number is the second set of quantum numbers. Students, here we observe that it is basically represented by small l. It is represented by small l. Okay. Now, the next basic thing that we need to remember it is that it explains about what? It is also referred to as subsidiary quantum number or angular quantum number. Right, students? It explains us about what? It explains us about subshells, right? Students, if L value is 0, remember this? If L value is 0, it is your S subshell. If L value is 1, it is your P subshell. If L value is 2, it is your D subshell. If L value is 3, it is your F subshell. Clear, students? So this is the basic thing that you always need to remember here. That according to the values of L, you need to find out which subshell it is. If L is 0, it is S. If L is 1, it is P. If L is 2, it is D. If L is 3, it is F. Now, the basic formula that we need to remember here is, it is about the number of orbitals in a subshell. How many orbitals are present in a subshell is represented by 2L plus 1. Kindly put a box here for this. Right? Okay. Now, we have seen that how many orbitals are present in a subshell is 2l plus 1. If I talk about electrons in a subshell, then you need to multiply this with 2. Why? Because one orbital contains 2 electrons. So if we are finding, this is the formula to find orbital, then what is the formula to find electron? Number of electrons. To find the number of electrons in a subshell, we need to multiply the number of orbitals with 2. Hence, the formula will be 2 into 2l plus 1. Right? Also, put this in a box. And kindly put a star over here because these formulas are going to be very important. These are going to play a very important role. Now, how to find the value of L? This you have already learned. How to find the value of L? To find the value of L, L is equals to 0 to n minus 1. Now, what is n here, students? N here is principal quantum number. N here is principal quantum number, which we have already studied, which represents the number of shell. Now, to calculate the value of L, what we need to do is we need to write the value of n. For the first n, okay, considering very first case, when n is equals to 1, what will be the value of L? L will be equal to 0 to 1 minus 1. What does that mean? 0 to 0. What does that mean? It means 0. So, when L is equals to 0, how many subshell will be there? Only one subshell will be there. That is going to be your S. We have already seen when L is equals to 0, it is known as S. So, we can say here it is S orbital. Right? Okay. Now, coming towards the next, when N is equals to what? The next category is when N is equals to 2. What is the value of L? L is going to be 0 to 2 minus 1 because the formula is 0 to n minus 1. So, what it is going to come out to be? 0 to 1. Now, what is 0 to 1? 0 and 1. Now, what is the value for 0? The value for 0 is S and the value for 1 is P. So, what we are going to see? We are going to see S and P. Clear, students? Now comes the next case. Okay. For the next case, students, when n is equals to 3, what is going to be the value of L? L, it is going to be 0 to 3 minus 1. That means 0 to 2. Now 0 to 2, what it contains? It contains 0, 1 and 2. Right? 0, 1 and 2. So, one thing more, students, here, 0 refers to as S, 1 refers to as P, 2 refers to as D. But this is incomplete. Why it is incomplete? Let me tell you. Also add one more point in principal quantum number here, that whenever you get any number, for example, if I talk 2S, 3S, 3P, like these. If I talk 2S, what is 2 here? 2 here is N. 2 here is the value of N. Right? So similarly, if I talk here, if I say how to represent them for the first shell, when n is equals to 1, I have to represent S. What is the representation? Whatever will be the orbital, the number will come in front of that. As I told you, n will be represented in front of the orbital. If it is S, then it is, if S subshell is present, then the number is represented here and shell's number is represented in front of that. Similarly, 1 will come here. It is known as 1s. That means when first shell is there, we will see what? We will see L is equals to 1s. When second shell is there, N is equals to 2. 2 will come in front of both of them, NS, NP. That means 2s, 2p. Similarly, in this case, N is equals to 3. So, it will come 3s, 3p, 3d. This is the complete representation, Now, this other than this, students, azimuthal quantum number is going to explain it about orbital angular momentum. The previous case, the principal quantum number told us about orbit angular momentum. Now, this is explaining us about orbital angular momentum. Both of these are different, Okay. So, last thing here you need to write is, it explains about orbital angular momentum. The previous case told us about orbit. It is explaining us about orbital. The formula will be L into L plus 1. Here, root will come, then h by 2 pi will come outside. This is the formula to calculate the orbital angular momentum. Clear, students? Now coming towards our next category, the third quantum number, that is refers to as magnetic quantum number. Students, magnetic quantum number is represented by small m. It is represented by small m. It explains us about the Zeeman effect. It give emphasis on Zeeman effect. Other than this, students, it also told us about the orientation of electron in space. Now, students, to calculate the value of m, what we need to understand is that m's value lies in between minus L to plus L. This is the basic formula to calculate the value of m. This is the basic formula to calculate the value for m. Now, students, the total value of m. This is the basic formula to calculate the value of m. The total value of m will be equal to 2L plus 1. Okay, this is the basic formula. See, whatever I am explaining, you need to just revise it thoroughly again and again and practice it on questions, because until and unless you won't practice, you won't get the concept. You are just listening and listening, that won't be last forever. If you want your concept to be stronger and would last forever, you need to practice, because more practice will make you more stronger and will make you the concept more deeply understandable. Right, students? So students, make your work interesting, and by making your work interesting, you will learn concept in very easy manner, and it will always be rememberable till your examination. So work hard, do practice, and do questions, right? Okay, now coming towards the topic again, these two formulas we are going to apply again on a table, and we need to find out what is the value of m, right? Okay, see, I'm making a table here. Kindly draw this with me and find the values, right? Okay. Students, first of all, you need to make a column for your, SP. One second. For SPDF, we are going to find for all these, right? For S, for P, for D, for F. The second most thing you have to write is the value of L for them. Here, you need to write the value of L. Right, students? The next thing, you need to write the value for M, which we are going to calculate from this given formula, right? Then students, at last you need to write the value for total values of L. Okay, total values of M. Right. So, let us start this table. Okay. Okay, students, for S, I would say what is the value of L? We have just understood in the previous case. For, S, the value of L is 0. So here we are going to write for S, the value is going to be 0. L's value is going to be 0. Now, what is the value for P? It is 1. For what is the value for D? It is 2. What is the value for F? It is 3, right? We have covered the L column. Now comes the M column, that is going to tell us about the magnetic quantum number. Now, to calculate the value of M, we need to represent as from minus L to plus L. That means if I go from minus L to plus L, please write the formula here, minus L to plus L, right? See now. Students, what is L here? 0. That means from 0 to 0. 0 to 0 refers to as what? 0, right? The very first thing is 0. Okay. Now, what are the total values of M? What are the total values of M? Total values of M is 2L plus 1. 2L plus 1. What is the L? L here is 0. So, 2 into 0 plus 1. What comes out to be 1? That means how many orbitals are made in S? Only single orbital. This number, explains us that only one orbital will be made. And in one orbital, maximum of electrons come out to be 2, right? Okay, now coming towards our next case, students, here we have P. For P, L value is 1. Now to write for M, it is minus L to plus L. That means minus 1 to plus 1. Now, minus 1 to plus 1. See, if you come across your mathematics, you have seen, a line. This is our 0 origin. And if I move towards the right position, it is 1, 2, 3, 4, 5. This is the number line, right? And if I move towards the left one, it is minus 1, minus 2, minus 3. Such way. If I am talking here about minus 1 to plus 1, that means I am moving from minus 1 towards plus 1. And it is covering the three numbers minus 1, 0 and 1. So it is equals to what? It is equals to minus 1, 0 and plus 1, right? So if I talk about the total values of M, what will be the total values of M? 2L plus 1. What is the value of L here? 1. So 2 into 1 plus 1, that is 3. That means total 3 orbitals will be seen. Like this, total 3 orbitals will be seen. And each orbital contains 2 electrons. Now what is this? Minus 1, 0 and plus 1. This is this. This is minus 1, this is 0, this is plus 1. It is 1. Clear? You can see that it is minus 1, 0, plus 1 here, right? Okay, now coming towards the D1. One second, students. If I come across the D1, what is the value for your L? The value for L comes out to be 2. When it comes out to be 2, it is minus 2 to plus 2 because M is equals to minus L to plus L. Now see here, minus 2, minus 1, 0, 1 and 2. If I move towards from minus 2 to 2, what are these values now? These are minus 2, these are minus 1, 0, plus 1 and plus 2. That means how many orbitals we will see now? 5 orbitals. So the total values of M comes out to be 2L plus 1, that means 2 into 2 plus 1, which comes out to be 5. So hence what we observe? We observe total 5 orbitals are seen. How many electrons, students, will be seen here? Total 10 electrons will be observed. Now what are these? Minus 2, minus 1, 0, plus 1 and plus 2. Clear, students? That you already know. S has 1 orbital, P has 3 orbital, Px, Py, Pz. D has 5 orbitals, which are these? Dxy, dyz, dzx, dx square, y square, dz square. It is the same way. Now comes up the F portion, right? To calculate the F portion, again minus L to plus L, that means minus 3 to plus 3. That means minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. How many orbitals, students? If we calculate the total values of M, it is going out to be 2L plus 1. 2 into L is 3 plus 1, that's come out to be 7. That means total how many orbitals will be made? Total 7 orbitals will be made. Hence, how many electrons will lie here? Hence, here 14 electrons will lie. First of all, to make electrons, you need to remember 1, 2, 3, 4, 5, 6, 7. Again, you will start here. 8, 9, 10, 11, 12, 13, 14. I am going to explain you further how to fill this electron. Don't get confused. Just for the sake of convenience, I am writing it all together. Right, students? Okay, so how many electrons are found there? 14 electrons. Again, I am considering it. S orbital contains 2 electrons. P orbitals are containing how many? 6 electrons. If I talk about D orbital, they are containing 10 electrons. If I talk about F orbital, they are containing how many? 14 electrons. Clear, students? Okay, so this was all about magnetic quantum number. Now proceeding towards our last quantum number, that is the spin quantum number. Fourth one is spin quantum number. Students, spin quantum number explains us about the spin of an electron. That our electron basically, revolves around two positions. One, the electron is revolving around its own axis. Another one is that electron is revolving around the nucleus. Basically, electron revolves around the two positions, right? So that's why electron exhibits two kinds of position. One is the clockwise direction, another one is the anti-clockwise direction. If electrons spins around the clockwise direction, then the spin is referred to as positive value, that is plus half value, when it is moving around the clockwise direction, revolving around the clockwise direction. But when it is revolving around what? It is revolving around anti-clockwise direction, then the spin, that means S, it is minus half. So electron basically revolves around the fixed orbital, and it also basically explains about its, the magnetic quantum numbers as well, right? So students, the spin represents here positive and negative symbol is just to represent its direction. The positive direction is representing that it is moving towards the clockwise direction, while negative is representing that it is moving towards the negative direction. So this was all about the spin quantum number. Now to calculate the magnetic movement for any of the electron, what is the basic formula? To calculate the magnetic movement, formula is square root of n plus 2 Bohr magneton. This is the basic formula to calculate the magnetic movement for any electron, which we find under the spin quantum numbers, right? So students, here n refers to as the number of unpaired electrons. Now what are these unpaired electrons? Now what are these unpaired electrons? See, if I talk about p orbital, there are basically in p subshell there are 3 orbitals, right? Now if I say there are 4 electrons present, then how many unpaired electrons are there? Pair refers to as a set of 2 electrons, right? If here is a set of 2 electrons, it is paired. Here only single electrons are present, that means they are unpaired. So how many unpaired electrons are found here? Are seen here only 2, right? A pair refers to as a set of 2 electrons, right, students? Now coming towards our next topic, this was all about the quantum numbers. With the help of quantum numbers and shape of electron, we are moving towards our next topic, that is node and anti-node. Now what do you mean by node? Node is basically a point, a plane, or a region, or a place where the probability of finding an electron is 0, where we can't find any electron. While if I talk about anti-node, it is just opposite to that, with that where electrons are seen, right? So if I talk about node, it is the region or place or point, any of these you can write, right, where probability of finding an electron is 0. Where probability of finding an electron is 0. Basically, there are 2 kinds of nodes. One is radial nodes. The another one is angular nodes. Now students, radial nodes are basically circular in shape, while if I talk about angular nodes, they are like a line or a plane like structure. Okay, now Angular nodes are represented by L. You know the basic formula for angular nodes is L, and if I talk about the formula for radial nodes, it is N minus L minus 1. This is the formula for, radial nodes. So students, if I talk about total nodes, what will be the value for total nodes? Total nodes refers to the sum of radial nodes and angular nodes. Okay, which comes out to be what? We will add them, n minus L minus 1 plus L. This will cancel out each other, which comes out to be n minus 1. So the formula for total nodes will be n minus 1, students. Now students, as we have seen what are nodes, what are types of nodes. One is radial one, another one is angular one. If you get confused, what is the value of n and L? N and L are the quantum numbers, just which we have studied. N refers to as our principal quantum number, while L refers to as our azimuthal quantum numbers, right? Other than this, students, if I talk about nodal plane, now nodal plane is the region where the probability of finding an electron is 0. But it is which region? It is the plane where the probability of finding electron is 0. So if I talk about Px, how to make Px? We have already covered this topic. To make Px, we have to make the, in this way. We have to make our dumbbell shape in this way, right? The lobes in this structure on the x-axis. So if I talk here in Px, what will be the nodal plane? If I talk about Px, what will be the nodal plane? The nodal plane will be the one in which the electron's probability is 0. If electrons are found in the region on the x-axis, because on the x-axis the lobes are made, that means the probability of electron is found here. So other than x, what are the axes where electrons are not found? It is y and z. Hence the nodal plane will come out to be yz. So here the nodal plane comes out to be yz. Why? Because on the x-axis electrons are present. So other than x-axis, which axes are left? Y and z. Hence the nodal plane refers to as xy. Yz. So here it comes out to be yz. If I talk about py, students, that means our lobes are found on the y-axis. Students, if lobes are found on the y-axis, what will be the nodal plane for this case? If it is present on y-axis, what are the other left out? X and z. Hence the nodal plane will be xz. Now for the next case, if I consider pz, if I consider for pz, what will be the nodal plane? Don't consider the z-axis. What are the left? Other ones are x and y. Hence the nodal plane is xy. Now students, let us make a table and sum up all of these in that, right? So if I make a table here, kindly draw with me. Okay, the first thing that you have to put here is orbital. The next thing you need to put is radial node. The next thing is angular node. The next thing is total node, and the last one is going to be your nodal plane. Okay, so here you have to write your radial node. Here you need to write about the angular node. Here comes out to be total node. And here comes out to be nodal plane. right? So this table you have to make. For first orbital, we are considering 1s orbital. I am taking 1s orbital. Now, for 1s orbital, as I already told you, if you see somewhere 2s, 2p, 3s, what is the value of n? N comes in front. Here n is 2, here n is 2, here n is 3, right? Clear? So, here in 1s, what is the value of n? Here in 1s, the value of n is 1. Okay, what is the value for L? When does S come? When L value is 0. L value 0 is referred to as S, then we can say that L here is 0. Right. Okay. Now let us put all of these in the situation. What is the formula for radial node? Students, we have just done it right now. Kindly put this in a table. All of these formula. This is radial node, right? Then our next one is angular node. This is angular node, and the last one is the total node. All of these three are most important, and kindly put them as a star also: angular node, radial node and total node, right? So here, what is the formula for radial node? N minus L minus 1. Formula for angular node: L, total node N minus 1. You have to put the same here. For your radial node, it is N minus L minus 1. For angular, it is L. For total, it is N minus 1. Clear? Okay. Now look here. Radial node, N is 1, L is 0. So what comes out to be? 1 minus 0 minus 1, which comes out to be 0. How many radial nodes? 0 radial nodes. If I talk about angular node, what is the formula? L. L here is 0. If we talk about total nodes, N minus 1, what is the value of N? 1. So 1 minus 1 is 0. Hence there will be no nodal plane because there are no nodes. Clear? So nodal plane is also 0. So now coming towards the next category, if I talk about 2s. If I take 2s, here n is equals to 2. What is the value for L? For S, the value is, for the SL value is 0, right? Now, if I talk about radial, what is the formula? N minus L minus 1. N is 2, L is 0, minus 1. It comes out to be 1. That means there is one radial node present. Okay. If I talk about angular node, what is the angular node formula? L. L here is 0. That means there is no angular node present here. If I talk about total node, what is the formula? N minus 1. N here is 2. So which comes out to be 2 minus 1. It comes out to be 1, students. If I talk about the nodal plane here, so students, now if I talk about the nodal plane here, what will be the nodal plane here? It will be 0. So hence, through this we can calculate it very clearly. See here. Next category is 3s. Next category is 3s. If I talk about 3s, n value is 3, s value is, for s the L value is 0. Clear? Now, n minus L minus 1, n is 3, L is 0, minus 1, hence it comes out to be 2. For angular node, its value is L, L refers to as 0. Total node n minus 1, that is 3 minus 1 is 2, students. And for nodal plane for S is always 0, right? Okay. Now, for coming towards the next category, let us take an example for 2p. If I talk about 2p, n is equals to 2 and L is going to be what? L is going to be 1 because for p, the L's value is 1. Right, students? Other than this, now what is radial node? N minus L minus 1. N is 2. L is 1 minus 1, which comes out to be 0. Hence, radial node comes out to be 0. If I talk about angular node is L. L is 1. Now, if I talk about total node comes out to be N minus 1. N minus 1. Now see n, what is the value of n here? 2. 2 minus 1 refers to as 1. Clear? Now the nodal plane here, which comes out to be what? We have already done for the case of px, py, pz, that if there is only one axis, then the nodal plane will also come. If the axis is like px, then the nodal plane is yz. If the axis is py, then the nodal plane is xz. Hence the nodal plane comes out to be 1. Clear, students? Okay. Now we are going to make it that how does it represent like? How does it looks like? So first of all, we are going to draw for 1s case, right? Okay. Now I am representing it. How does these nodes look like? Representation. Okay. Now students, to represent, first of all, I am taking the case for 1s, which we have already written all of these situations, right? For 1s, how does to represent it? See. This is my nucleus, which is positively charged. 1 refers to the value of n. N is equals to 1 here. That means only one shell is present. Only a single shell is present here, students. So what does it represent us? Is there any node present here? Is there any node present here? Here, no node is present here. Here, no node is present here. What does it represent? It represents that electrons are present in all of these regions. Electrons are present in all of these regions, you know. When there is no node, then that refers to as the probability of electron, that electrons are present here, which makes it as a spherical shape, which makes it a s orbital. If I talk about the next case, students, next case is 2s. So for the case of 2s, I would say that this is my nucleus, this is my first shell, this is my second shell. How many nodes are present here? How many nodes are present here, students? See, for 2s case, radial node value is 1. Okay, for 2s case, the radial node value is 1. That means there will be one spherical region where the probability of finding electron is 0. If it is 0, that means there the probability of finding electron is not 0. Everywhere electrons are present. Everywhere electrons are present. Okay, if I talk about 2s, there is a single radial node. Now, to how to represent it? See, this area is our radial node. This area is our radial node, students. Here it is that one region where the probability of finding the electrons is 0. The green portion which I am showing is the shells where the electrons revolve. Here the green portion which I am showing is the shells where the electrons, students, revolves, right? Okay, so here you can see that angular node is 0. Angular node refers to as the plane or line, that is 0. Only here spherical node is present, and spherical nodes are known as radial nodes. This was the case for 2s, students. Now coming towards our next case that I would talk about is of, we take an example of 2p, right? If I talk about 2p, students, what is the structure for, p orbital? This we have already done before. For p, so no need to do this. I'll just show you again the same structure for the nodal plane. See here, for px the nodal plane comes out to be yz, for py the nodal planes comes out to be xz, for pz the nodal plane comes out to be xy. So I am going to take the case for d orbital now, because p orbital we have already done the nodal planes, right? So for d orbital, if I take d orbitals, basically I am going to take the first case for non-axial one. Non-axial ones were dxy, dyz and dyz, right? Now if I take the case of dxy, that means my lobes were like this, which are present in between the axes. Which were present in between the axes. So you can calculate same formula for these cases also. If you have been given for any of these, for example, you are given for 4D, then you can calculate for these, like the radial node, you can calculate for these like n minus L minus 1. Again, the formula for angular node, you can directly put the value of L. L comes out to be 2, right? For total node, you can put n minus 1, and for nodal plane, you can calculate these. Now, students, if I talk about what? If I talk about the axial ones basically, axial ones, for example, dz square. If I talk about dz square, where is the probability of finding an electron? See here, if I talk about dxy, the probability of finding an electron on the x-axis and on the y-axis is possible. Yes, it is possible here also, because electrons are found in between the axes. But if I talk about the axial ones, that is the dz square. This is the structure. So here, students, in the case of dz square, no nodal plane as such is seen, but two cones are formed which represents just like the nodal plane. Just I am explaining it you all again. If non-axial ones are present, in the non-axial ones, what we see, the lobes are made in between the axes. That means the nodal planes are this and this. Other than this are the electrons. This and this are the area where electrons are not present. But if I talk about the axial one, for example, if I take the case of dz square, here what will be the nodal plane? Here are no nodal planes seen, but the two cones are made. What are these two cones? These two cones are somewhat like this. These two cones are made, which represents like, yeah, which looks like nodal plane, which is just similar to nodal plane. Clear, students? So in the case of axial one, they don't have the nodal planes, but it looks like that. Clear, students? Now we will move forward towards our next topic. So students, now we are proceeding towards our next topic, that is electronic configuration. Basically, how we need to write electronic configuration is very, very important for any examination point of view. You need to remember the basic 3 rules for writing any electronic configuration. The very first rule is going out to be Aufbau's principle. Aufbau states us that whenever you are writing any electronic configuration, that means whenever you are filling electrons in any of the orbitals, the orbital with the low energy should be filled first and the orbital with the higher energy should be filled afterwards. So this was the basic principle that which he kept in his mind while writing the electronic configuration. Now I'm going to tell you the energy, the energy trend that is being followed, which with the help of which you can write any of the electronic configuration with any of the atomic numbers, right? So first of all, you need to draw with me. I'm making it a bit smaller. Okay. Now this is your first series, right? The second one. Now comes out to be the third one. You can even draw these in your NCRTs. Now comes the fourth one. Okay. Now, let us fill them. Students, this is your 1s, this is 2s, this is 3s, this is 4s, this is 5s, this is 6s, and this is 7s. The next one is 2p, 3p, 4p, 5p, 6p, 7p. The next comes out to be 3d, 4d, 5d, 6d, right? The next comes out to be 4f, 5f, right? Now, how to fill these electrons? Let us understand this. See, what we need to do is we need to move from this direction. First of all, you are moving in this direction, right? The next step is to move inward. Remember this. First you are moving in this direction, then you are moving inward. Now, in the next phase, you are again moving towards the ball, right? Now again you are moving inward. So you need to represent like this. You are moving inside, then you are coming outside, then you are moving inside like this. See, you are moving inside, you are coming outside, you are moving inside. Whenever you are moving inside, you have to move on the balls. And whenever you are moving outside, you don't have to touch any of the balls. See, I'm moving inside, I'm touching this 1s. When I'm going outside, I'm not touching it. I'm not crossing it, right? So when I'm coming inside, I'm touching it 2s. When I'm going outside, I'm not touching it. That means I'm not considering it. Now coming towards the next one is this inward. Now moving towards the outward, right? Now during the inward, I am coming across. Now moving outward. Now coming inward, these 3 balls are being covered. Now if I move outward, nothing is being covered. That means during coming inward, I have to cover all the balls, right? So I'm coming inward, I'm covering all these balls. Now I'll move outside without covering any balls and coming inside covering all these balls, right? Now I'm moving inward, not covering any balls. Like this I have been covering, right? So this is the basic trend. I am going to write it here in front of you. So the very first is 1s, right? Very first is 1s. After that, what is 2s? The very next, students, you see, here I am going, it's 2p. Then after 2p, what's it is there? 3s. Okay. After 3s, I am coming across what? 3p. After 3p, what I am coming across? 4s. After 4s, what I am coming across? 3d. Right? After 3d, what I am coming across? 4p. After 4p, I am coming across 5s. After 5s, students, I am coming across 4d. After 4d, I am coming across 5p. After 5p, I am coming across 6s. After 6s, I am coming across 4f. After 4f, I am coming across 5d. After 5d, I am coming across 6p. After 6p, I am coming across 7s. After 7s, I am coming across 5f. After 5f, I am coming across 6d. After 6d, I am coming across 7p. So this is the basic, electronic configuration trend that we need to follow Firstly, where we need to put electrons, we will put electrons in 1s. After that, we will put electrons in 2s, then in 2p, then in 3s, then in 3p, then in 4s, then in 3d, then in 4p, then in 5s. Then in 4d, then in 5p, then in 6s, then is 4f, then is 5d, 6p, 7f, 7s, 5f, 6d and 7p. So this is the energy diagram. Like first of all, when you are given electrons, you need to fill in this, then in this, then in this, and like this. As soon as you move in these directions, energy is increasing. Energy is more of these orbitals. Clear? So first of all, we need to write the principle for the Aufbau, that lowest orbital will be filled first. Remember that. Lowest orbital should be filled first. Okay. Now comes Aufbau's rule. Aufbau's rule, what does it tell us? N plus L rule. Basically, what is N plus L rule? N plus L rule refers N plus L rule is used to determine about energy. It tells us about energy. The value for N plus L, whose value is N plus L is less, will have less energy. The value for N plus L is more, will have more energy. This is the basic formula. But when N plus L value is equal, then the number which has N's value as small will have low energy, and the number which have N value more will have more energy. So for example, if I take case of, let us take a case of 3s and 4d, right? If I take off case of 3s and 4d. Okay, now tell me the N plus L rule. What is the N here in 3? N is 3 here because the number in front of it refers to as N. What is L here for S? L is 0. Now for this, N is equals to 4. What is L here? C. L is 0 for S, 1 for P and 2 for D, right? So N plus L rule here is N plus L is 3. Here N plus L is 6. So which number is more? Obviously 6 is more. That means 4D has more energy than 3s. That means 4d has more energy than 3s. So do remember this rule. Also, please do mark that when n plus l value is same, when n plus value is same, when n plus l value is same, n is low, that means energy is less. The orbital whose n value is low will have less energy. The orbital whose n value will be more will have more energy when n plus value is same. So these two are important and you need to remember them, right? This is the trend, right? So students, this was our very first principle, that is Aufbau principle. Now proceeding towards our next rule for writing the electronic configuration is basically the Pauli's exclusive principle. Now, what does Pauli explained us? We need to understand this. First of all, according to this principle, you need to see that no two electrons can have same value of all the four quantum numbers. For example, if I take case of 5s2, now s2 refers to as that s orbital has 2 electrons, right? Now these 2 electrons will have different values of quantum numbers. How? See, if I write these first electron and here about the second electron, I am writing the information about that. What is the value of n here? N here is 5. For the second electron also n here is 5. What is the value for L, students? For S the value of L is 0. Here also L will be 0. Now what is the value of M here, students? If I talk about M value is refers to as minus L to plus L. We have already covered. If L is 0 then M is also 0. M here is also 0. Now if I talk about spin quantum number, for the very first electron it can be plus half and for the second it will be minus half. So here we can see that at least one is different. That means not all four quantum numbers are same. There will be one that will be different and that one is the spin quantum number. That means whenever you are representing any of the electrons, one electron should be in upward direction, other electron should be in lower direction. What it is explaining to you is one is in clockwise direction, another is in anti-clockwise direction, right? So always we represent it in this way. We never represent this the same spin. This is wrong, or I would say this is wrong. The same spins are always wrong. Always electrons are present in opposite spin. If one is plus half, other is referred to as minus half, or if first one is minus half, the other one is positive half, right, students? So let us see what they have written about the rules so that it will be more clear to you. See, according to this principle, in an atom, no two electrons can have same value of all the four quantum numbers in the same orbital. Kindly mark this line as important. In the same orbital, electron always accommodate in opposite spin. Always remember that they accommodate in opposite spin. The very next thing you need to remember is this we have already done. The maximum capacity of electron in our orbit is 2n square, right? Okay. Maximum capacity of electron in a type of orbital is 2 into 2l plus 1. This also we have already done. These two formulas. But if you need to remember it, kindly mark it as important. And the last one. And the very last one, students. An orbital can have maximum of 2 electrons with opposite spin. Very, very important. Always there will be an opposite spin. Right? Always there will be an opposite spin. Do remember that. No same spin can be observed. Opposite spin. That means one in the upward direction, another in the opposite direction. Clear? This was the second rule for writing the electronic configuration. Now the very last rule is the Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity explains us that first of all, in any orbital, whenever you are filling electron, electron should be filled in such a manner that each orbit should get minimum 1 electron. It should not be like this that first orbital is being filled, then you are moving towards the next orbital. No. First of all, you need to take care that each orbital should get 1 electron. Then you will proceed towards the filling of next electron. How can I say that? Let us see this. For example, for the case of nitrogen, basically what we see here is, basically nitrogen have 7, atomic number. It has 7 atomic number. That means we have to fill 7 electrons here. Now to fill electrons here, first we will write the electronic configuration. How to write the electronic configuration? Coming towards this case, we need to fill how many electrons? 7 electrons. S orbitals has how many electrons? S orbital has maximum of 2 electrons. 2 electrons will be filled in 1s case, right? See, 1s will contain 2 electrons. Okay, now 2 electrons are filled. How many are left? 5 are left. Coming towards this, again after 1s, where the electrons will be filled in 2s. Now we will write 2s. S orbital contain how many electron? 2 electron. 2 electron will be filled. How many are done? 2 to 4. How many are left? 3 electrons are left. 3 are left. Now next comes out to be 2p. You have to fill in 2p. So if I fill in 2p, students, p orbital contains how many electrons? P orbitals are total 3. They contain 6 electrons. How many are left? 3 electrons are left. So we will write 3. So this is the electronic configuration. Now you know how to write. First you need to take this rule. You have to fill in 1s, then you have to fill in 2s, then you have to fill in 2p, then you have to fill in 3s, like this way. Always remember, s orbital maximum 2 electrons, p orbital maximum 6 electrons, d orbital maximum 10 electrons, f orbital maximum 14 electrons. So this is the basic thing that you need to keep in your mind while filling the electrons. First of all, as I told you, in nitrogen case, we have filled in 1s, then we have filled in 2s, then we have proceed towards the 2p. 7 electrons should be filled, so we know that s contains 2, we have done 2. 2s will contain 2, we have done 2. 2p will contain 6, but we need only, we have to complete the 7 numbers, so 3 are required, so we will fill 3. Now how to represent it, students? First of all, we know that s orbital is single one orbital. How many electrons? 2. We have to represent it in opposite spin, right? Now 2s has 2 electrons. In the opposite spin, we will represent according to the Pauli's exclusive principle. Now we know that p orbitals are basically 3. How many electrons? 3. Now according to the Hund's rule of maximum multiplicity, each orbital should get minimum 1 electron first. Now 1, 2, 3. This is the correct manner. Some of the students, what they do is, when they are filling 2p, what they do? 1, 2, 3. This is the wrong way. First of all, each orbital should contain at least 1. Then this is possible. Then this is correct, right, students? Okay. Now let me read this to you. According to this rule, electrons are distributed among the orbital of a subshell in such a way so as to give the maximum number of unpaired electrons with a parallel spin. Spin multiplicity. This rule is important. Kindly please put a star over here, because it is important for you to understand, right? Okay. Now, where S is the magnitude of sum of total spin quantum numbers of electrons present. Now, students, fully filled orbitals are always most stable due to spherical symmetry. The fully filled orbitals in which all electrons are filled are the most symmetrical one, which we need to remember. Thereafter, half-filled orbitals are more stable than the other electronic configuration due to maximum spin multiplicity. What they are saying is, they are saying when there is an orbital which contain all the electrons filled, it is the most stable one. After this, the half-filled one will come. The half-filled are these one. These are the half-filled ones, which in which each orbital at least have 1 electrons. It is the most stable one. And after the half-filled one are the other electronic configuration in which 1 electrons, 2 electrons or 3 electrons are found. So these are the basic 3 rules which you need to remember. Now we will practice one of the following cases where how we can write electronic configuration, and the other one are the abnormal electronic configuration. We will practice these two both. First of all, I am taking a very simplest case of hydrogen. After that we'll do abnormal. Okay, if I talk about hydrogen, what is the atomic number? 1. So what is the correct way for electronic configuration representation? If we follow this rule, first we need to fill electrons in what? In 1s. When we need to fill in 1s, how many electrons we need to fill? Only 1. So its electronic configuration is 1s1. So how we will represent it? We know s orbital is single and it has only 1 electron, right? Now the next case is helium. Helium basically has 2 electronic configuration. So how we will write it? We know that first of all we have to fill electrons in what? In 1s. So we will write 1s, and we know that in s orbital maximum 2 electrons are kept and its atomic number is also 2. So 2 will come. So correct representation will be 1 in the upward direction, another in the downward direction, that is the opposite spin, right? The next comes out to be lithium. Its atomic number is 3 basically. Now how to fill electrons? First we need to fill electrons in 1s, then in 2s, right? So we know that first we need to write in 1s maximum how many electrons in s, 2 will come. Then we need to write in 2s maximum how many, 2 will come. But we need to fill 3, 2 plus 1, that is 3, right? Now to represent it in 1s, how many are there? 2 are there. In 2s, how many are there? Only 1 is there. This is the correct representation, right? This is the simplest case that you can do. For nitrogen, we have already done, students. Now coming across, let us take an example of abnormal electronic configuration. I am taking the case for chromium. I am taking the case for chromium whose atomic number is 24, students. First of all, we are talking about chromium. Chromium has an abnormal electronic configuration. What do you mean by abnormal? Abnormal is the one when you are writing the electronic configuration, something is different with respect to the other elements. Other elements I have shown you, you can fill in such a situation. But when I talk about chromium, it is quite different. How it is different? Let us see that. But before that, let us take one more example to make it more interesting of sodium. Sodium has an atomic number 11. Now to fill for sodium, we need to first fill in 1s, then in 2s, right? So 2 electrons in this, 2 electrons in this, because s can contain maximum of 2 electrons. How many electrons are filled? 4. Maximum 11 you need. How many are left? How many are left, students? 7 are left. After 2s, we have to fill in what? 2p, then 3s. Right? So we will fill now in what? We will fill now in 2p. 2p. Now p orbital contain maximum how many electrons? 6. Right? So let us count this. 2, 2, 4, 4 and 6 are 10. Now what is the next one? If I come across the next one after 2p is what? After 2p is 3s. After 2p is 3s. So here in 3s, how many electrons? 1 will come. So it is 2 plus 2, 4, 4 plus 6 is 10, 10 plus 1 is 11. Now this is the correct representation, right? Now for chromium, similar way, I have to first fill in what? I have to fill in 1s. 2 electrons are filled. Then I have to fill in 2s. 2 electrons are filled. How many are done? 4 are done. But we need to do 24, right? Then we will fill in what? 2p. Then we will fill in 2p according to the Aufbau principle. How many electrons maximum in p? 6. So let us count it. 2, 4, 4 plus 6 is 10. Then comes out to be 3s. How many? 2 will be done. In s, basically 2 are done. How many are done? 12 are done. After students 3s, what do we get? 3p, 4s. Right? After that we get 3p and 4s. Now comes 3p. We know that in p basically 6 electrons are found. So we have written 3p 6. Right, students? Now if I count 2 to 4, 4, 6, 10, 10 plus 2, 12, 12 plus 2 is 12, 12 plus 6 is 18. Right, students? Now the next case after 3p we see is, 4s. After we see 3p is 4s, then comes the 3d. So we are filling 4s as 2 and then comes 3d. Now let us count it. 2 plus 2, 4. 4 plus 6 is 10. 10 plus 2 is basically 12. 12 plus 2 is basically 12. 4, 10, 12. 12 plus 6 is 18. 18 plus 2 is 20. 20 is done. Now 4 are left, student. What you see is 4 are left. But it is wrong. It is wrong. Why it is wrong? Because it is abnormal. Something is different here. What is different here? The different thing is that now this one electron will be shifted towards this to make it more stable. Now what will be the abnormal electronic configuration observed here? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. This is the electronic configuration that is observed here. Not this one. It should be like this, but it is not like this, because to make it more stable, the d orbitals, at least one orbital should get 1 electron. So 1 electron is shifted from this to this. This is the abnormal electronic configuration. Now taking one more example in the case of abnormal is of Cu. The last case is for Cu, whose atomic number is 29. 29. Now, if I talk about Cu, students, again I need to write all this. I will write 1s2, 2s2, 2p6, 3s2, 3p6. Now see, 4s2. Now see, 2 to 4, 4, 6, 10, 10, 12, 12, 18, 18 and 2, 20. Now I have to fill 9 electrons more to make it 29. And in D, I know that maximum of 10 electrons can come. Now, my electronic configuration should have been like this, but it is not like this. It is abnormal. What it comes out to be? It comes out to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. This is the correct electronic configuration. Now students, you need to remember this. This is the correct electronic configuration for the case of Cu, right? Okay. Now students, this ends our chapter structure of atom. So before ending, always remember one thing. Never say I can't. Never say I can't. But ask yourself, how can I? Ask yourself, how can I do this? And you have that potential that you can accomplish any of the problem, you can fulfill any of your dreams just by doing hard work, just by the consistency that you make day in and day out. So practice today all the questions that we have done in this chapter. Thank you so much. We will see you in the next chapter.